I'm going to share my screen first. Good morning, class. Today is 4/25/2020, and we're going to discuss database continuation of what we discussed last week with discussion of Python and MySQL. So the modules that are installed, or the modules that are not installed as default, we discussed some of them, and then we are going to, we did some demo, and we're going to continue using SQLite and MySQL in this session today. I prepared some of the pre-installation already for both SQLite and also MySQL on the Windows server, and we're going to demo that one, and then maybe future sessions I could do it on the Unix side as well for you, depending on the rest of the materials that I need to cover for and the topics that are left, and as well as the time that we have left. So last time we discussed the database terminology, and we say that what is database? Basically, database is similar to operating system, except it manages table spaces and schemas and users and kind of tables, views, indices, and so on. But a database, the core part of it, of a database, is DBMS, Database Management System, versus the operating system manages binaries and device drivers and utilities, and those utilities and binaries and everything that gets together is called operating system. The core part of the operating system, or those device drivers and utility that works on the behalf of the operating system to handle user interface, to handle like CPU management, memory management, IO management, device management, process management. And the same thing with DBMS, database management systems. The core part of it handles log writer, DB writer, system writer. Everything has to do with instance of a database. The memory management part of it, as I mentioned, on relational database like MySQL, Oracle, Sybase, most of them, they have a daemon and background processes that are called log writer, system writer, DB writer, that actually writes and reads from the database and or from system tables, from metadata, and then as well as table spaces that are defined by users and everything. And then on top of it, there's a memory part of it that is called SGA, System Global Area. And then there's also PGA. But inside the SGA, you have like the Java pool or the SQL pool commands that are coming from the queries. So in this case, we talked about SQL, a structured query language, or a standard query language. And both names are used interchangeably. And for a database to work different than a flat file system, for example, normally on the smaller lightweight management, there's a SQLite software that you could do database inside like a flat file, just one file that has all the queries that you could do within that file, but it is growing similar to a bigger database instance like MySQL, Oracle, and Sybase, and Formix. And those ones, when you do it, basically, if the files are growing, you could have inside one database, instead of one file on SQLite, on the MySQL side, you could have multiple DB files. So the database writer has to take care of it. And on top of it, you have control files that the DBMS has to manage those ones. and you have log writer file, and then inside each of the DB file, you could have table spaces. And table spaces contains tables, indices, views, and user kind of information. And there's one instance of a database could be called a schema. The schema or the profile for a given user. And this, let's say the account is called root account, has its own schema. The account DB account has its own schema. So a schema is per user, per profile. And then inside the schema, you have the table spaces, the indices that are inside the table space, the tables, the views, everything else. All the informations are stored there. And then inside the table, you have, on a relational database, you have a relation between multiple tables. When you create 10 tables, those tables are somehow related to each other using a foreign key, primary key relationship. Every table, in order to make sure that tables are normalized so they don't have duplicate records, then you just have a primary key, foreign key relationship. And those foreign relationship, primary key for foreign relation, those primary key, foreign key relationship could be one-to-one relationship, meaning one record matches one record of another table, or one-to-many, meaning one record, for example, one instructor could have multiple classes, or one student can take multiple classes, or one student could have multiple majors. That's one-to-many relationship. And then many-to-many, one instructor, many instructor could teach many classes, for example. Many students could take many classes. Many students could be registered to many different buildings, and so on. And then this relationship basically makes a database more robust in terms of query, because you could just join two different tables, either inner join or outer join, and then get record out of it. And then those information that you do with SQL command, basically it is making a database more robust in a sense compared to a flat file. Because on a database, normally before you create a database, and then you create these table spaces and create these tables, you have to create a database with something in mind to just make sure the database does not allow any duplicate records entry in comparison to a flat file system. For example, on a flat file, when you open an Excel spreadsheet or let's say Word document or a text, sometimes you could put certain information to be restored. But if it's a student record, imagine if you put it on a flat file. When you put it on 1,000 students' information there, this flat file could grow so fast, and then unfortunately, there's going to be duplicate entry on it. Some student, maybe student number 5, could be entered 3 times, 10 times. There's no way in the flat file that you can control it. But with a database and every table, you could normalize the tables to not have any duplicate entry. So that would be your first normal form to say that every table that I create has to have unique primary key that makes a record unique inside a table. So the definition of the primary key, I told you that primary key is one or more fields in a table that makes the record unique within that table. If you have 1 million records in a table, it's still the primary key if it is defined as social security, or maybe the DMV license or student ID or something else, whatever, let's say the table name is called major, and then major ID would be just a unique name and that you could assign it to it. And then that would just eliminate duplicate entries in that table. That is the first normal form. And then sometimes you could just say, it is not just one field like social security. So it could be multiple entries on the table that could also make it unique. So one or more field. That's why we come up with a definition of certain number of keys. For example, the keys that we discussed, we say that there's primary key, foreign key right here, primary key, foreign key, candidate key, alternate key, foreign key, and secondary key. Those keys are really important. So compared to choosing the primary key, all the fields that are on the table, they're candidate to be a primary key. So that's why they're called candidate key. But once you choose the primary key to say, let's say first name, last name, address is the combination of primary key that makes it unique in this record, then the rest of the key from the candidate key become alternate key that later on that you see some anomalies comes in and you couldn't do update anomaly or insertion anomaly or something, then as a result, you just decided to do another key. So then you alter the table space, the data definition part of it. We discussed about SQL, that supports three type of languages. One of them was data definition language. Data definition language is basically the type of language on the SQL that allows you to create tables, create indices, create users, create synonyms, create any objects, and then destroy them, like delete them, drop them. Those ones defining a table, defining the data. That's why it's called data definition language. So if you say create table, if does not exist, then name of the table, that's just a definition of a table. Create user identified by password, that is just telling it to define data structure inside your DBMS. So data definition language or examples I wrote here is create table, indices, create views, create users, drop tables, drop indexes, drop views, and so on. And then there's another part of the data definition language was one. The next one is data manipulation language, how you manipulate the data. Those are your update statement, insert statement, select statement. When you're selecting something and then inserting that record in another one, that's also called data manipulation language, because the where clause on the selected statement filters out or earlier sorted for you to say sorted by this order, and then at the same time inserted. I'll give you some example of these ones from the MySQL or SQLite command line as well today. And then there's the data control language. The data control language allows you to control the data as it says. Like for example, you want to grant a certain access to certain users, say grant, let's say, connect, and then to connect to the database, connect, and then other privileges, all other privileges that are want to assign to this users. For example, read access on select access, update access, and insert access. You grant those access privileges to a user, and then you revoke it if you don't want to give it to the user. That's data control language. And when you do the grant and revoke, sometimes you could do it with cascaded option. Cascaded option is nice because with that option, sometimes you take care of dependencies. And in a database, as I mentioned, there's a relationship that you are joining multiple tables. Imagine that you have a student record, and then you just want to drop a student from a class, and then at the same time, maybe there's a financial aid part of the students, or maybe the way the students actually registered and paid for it. So all that has to go on a different table, how much it was paid. When you drop the student, it has to go to all the other tables that are related to this table for this student ID that you're providing as input, and then remove the records that are supposed to be removed. For example, if you drop a class, you make sure that you get reimbursed for that class, and or there's any other update that needs to be done, it needs to be done with those as well. In the example of an employee, when an employee leaves the company, normally all the dependents, the children that are there, or the family members, the spouse, when they are there, they normally are removed from all the subsequent tables as well, because this employee is no longer there. Otherwise, you don't want to continue with certain insurance and other stuff are bound to another table for the same employee ID that the parent employee ID is the process is no longer available. So these are called anomalies. If you don't do these ones, normally there's insertion anomalies, update anomalies, delete anomalies, and with cascaded option, you could just take care of these ones. But if your the database was not normalized, which means on a second normal form or a third normal form, you have this problem, then obviously your database is not performance tuned properly. When the database administrator created the tables, he or she did not create any I'm sorry, he did, or she did not create any primary key foreign key relationship and made sure that the insertion, update, deletion, those anomaly doesn't exist. Otherwise, it's going to just, the database is going to have duplicate records, and there's going to be a process that will have insertion anomalies or deletion or update. For example, with a student record, if you say the prerequisite for computer science 101 is calculus 101, and then the student does not have the prerequisite met for calculus 101, when the database is going to register the student at the time of registration, it has to check for those dependencies on the prerequisite requirement. And if that constraint is met based on certain table saying that yes, this student has that thing, then the insertion should be successfully submitted. Otherwise, the insertion is going to fail because the student did not do it. And if you didn't do a normalization on a second normal form or third normal form to get rid of these anomalies for insertion or update anomalies, then obviously that database is not going to work all the time. Sometimes you say, oh, for this student, manually I override the case because of this condition, but the database did not know it. And now when you're doing the query, that report is not going to do it. So the database also has some form of generating reports. So you have report writers within the SQL statement that you could create a form for students to be entered with registration information, and then that information gets stored in the database, then later on you query it. So SQL, structured query language, you do certain query, and then out of the 10,000 student or 30,000 student in our case, you just select a certain information, and that's much faster. And how do you do that speed? Within the 10,000, you create indexes inside index or indices. When it's multiple, you just say indices. So you create index in the database to just search for that record. At this time, I'm gonna just go look what else I need to cover here. Normalization. We discussed the normalization. There's first normal form through third normal form. And as I mentioned, there's bias coded normal form, which is sometimes they call it 3.5 NF or fourth normal form. So the fourth normal form is, or 3.5 normal form, and that is the bias coded normal form, and that I explain here the detail of it with as a normalization is used in the database. It is a slightly stronger version of third normal form. When I'm talking about normal form, you have to understand first normal form, second normal form, third normal form. And when you get into the bias coded normal form, your database is normalized. If you go for every constraint of, okay, insertion anomaly is taken care of, deletion anomaly is there, update anomaly is there, by that time you're going to this third normal form, which is the last strongest normal form that makes all the records in a database unique by identifying primary key, foreign key relationship, and looking for all the constraint. For example, in the database, you have this constraint that's called not null or null. Most people, they just incorrectly define some of these terminology, null, and they say that, oh, this is a data type in a MySQL database or something. The fact that you're saying it's not null or it is null, you have to understand that sometimes a null means the data is missing or the data is not known at this time. The value is unknown. So when you do the data entry, for example, in a case of DMV, for example, a car crash, somebody has a hit and run. And then when the car accident happened, the second person who did rear-ended the first person, let's say, and then maybe his car was good and he was not honest. He just ran away from the situation, and nobody knew who this person was. Now nobody knows about the second car information to report to the DMV the damage that was done on the first car. So all those record information that should have been stored as the second car driver ID and DMV license and other things are missing. When that information is missing, it is you could store null value, saying that at this time it's missing, but later on maybe it is going to be entered. And then sometimes on your fields, when you do the normalization and you say this table is having these primary key and foreign key, and these other fields are having not null value, not null meaning that it is not going to accept like non-string or non-integer values. So empty value cannot be inserted. And that's what those ones are. And there's a lot of other constraints. The constraints are normally created based on the business roles. So every business, every company that is running their business, they have certain roles. And based on those roles, you create constraints saying that in this situation, what kind of data is acceptable, what kind of data is non-acceptable. And that's what those constraints are. So let me show you with, last time we discussed also SQLite there. Let me just start SQLite here. Okay, with SQLite, the nice thing about SQLite is it is a lightweight version of SQL. It, in opposed to MySQL, Oracle, Sybase, those ones are the full version of MySQL that has a bigger database, the bigger DBMS, bigger table spaces, users, and form builders, query builders. There's more tools for developers to build an application within a database. MySQLite, on the other hand, is a small version of SQL-based, which you could do it with browser, like you say, SQLite browser, or just download the binary, which we did last week. And I have the documentation already on the last week presentation, how you should install this. And if you have questions, send me an email if you have not done an installation of it the way we did it for this class. I also did MySQL and afterward, but MySQL was having an issue on the instance that we were trying to do. I think it was my network at the time, but because we were using a VirtualBox and then the network was too slow. So I postponed the installation to do it on the Windows, and I prepared some documentation for it that I will post also. The documentation basically is, I'll go through that one, MySQL, after this. So let me just go to SQLite first, so you're not getting confused with anything. Let me make this screen bigger. Okay, this is your SQLite interface when you start the SQLite. So inside SQLite, you can just create a new database. You could open an existing database and then open projects and other stuff over there. It has a menu that you can have the options. As you can see on the previous example we did for CIS 012, we went through this directory SQLite, and I created a mydb.sqlite or my db. So I could just go under file and open that one, or just there's like SQLite. There's you can create based on memory. Based on memory is one time per process. So every process will create a new instance. And the syntax of the connect for SQLite is colon memory colon inside that parameter that you pass on when you do it within Python script. So you import SQLite 3, and then inside, once you import SQLite 3, and then you say connection con is equal SQLite 3 dot connect, and then within the bracket parentheses, you put colon memory colon. That tells it to read from the memory. We can go through some examples with that as well. But if you're not creating based on memory, the fact that you're doing with based on memory, it's a little bit kind of neat, as well as a little bit kind of like not good, because once you do it on based on memory, that it's lost. The next time you do it, it's going to just do it. So if you create a database called DB1, I mean, you worked on a memory base, and inside you create a table called table 1. This table 1 created there, and you insert one record there. The next time you want to insert the same record again on memory, because the memory gets fresh as a new process, that process is not going to be the same as previous one. So this record could be inserted a second time. And if you create table 1, you don't have to say if table 1 exists, create table 1 if it does not exist. If it, you don't have to say it, because it's based on memory. The last time that you created that table, it is already gone. It is no longer there. It wasn't in a flat file or the database file that had a table that was committed, and then you know the word commit and rollback. Whenever you do something on the data definition of language of SQL, you have to either commit it or roll back to it. When you're defining a table like create or insert or update, when you do that one after your transaction, you're doing a commit or a rollback. And then I mentioned last week that the transaction is atomic, meaning that it's either done or undone. So at the end of your query statement, you either commit it or roll back to it. Otherwise, that transaction will be in dangling state, and database, you don't want to do that, because imagine that somebody deposit the money and then they're going to another state and they're trying to query it, or another bank's branch, and they're trying to withdraw now, then it doesn't show that the money that they did is already there because it was not committed. So at this time, we discussed the memory, but normally you want to create a database on a file. So when you create a database based on a file, now if you created that table one again on the file, the next time you want to create that one, it says already exists. It is not going to allow you to create that table. But in the other terminology of normalization, when you create a table, if you did not create it a primary key for it, and then you want to insert that record, last week I showed you for the example that was showing on the book that had issue with normalization. Those three fields, none of them had any, I think, as primary key defined, so you could have multiple record. Every time you insert it, you could have maybe thousands of duplicate lines of records if you did insert 1,000 times, because there's no way the database would know that this is a duplicate record. You did not have that constraint of defined as primary key for any field. So when you do the new database, if you did not have any primary key in any foreign key relationship, it is a good idea to just say, create this table if it does not exist. But the insertion problem will not be resolved. So that's why on the first normal form, you may be able to do it in a way that, okay, I created the table, maybe inserted one record, but as soon as you try to do insert the second record, then on second normal form, the bias coded normal form and third normal form, they will check for these other data manipulation language, which could be insert, update, deletion. And then as you do say insert new record, that new record is not actually new record because it already existed in the table, and then you're inserting it a second time. Imagine when people are registering students, they're not going to know 30,000 students that when they registered or something. So the database has to have a way to manage that one. It's the job of DBMS. In this case, if I just create on a new database, I could just create that one. Let's say I just say a new database. It just basically tells me where I want to create the database in this case. So let's just go to one of the directory, for example, pasadena.edu, CIS12, and then SQLite. And I'm going to just say new DB, as simple as that. And you could call it SQLite, it's fine, new DB.SQLite, just to say whatever you want to name it. This is a SQLite database. So later on, you don't get confused with the name of the database, because that database actually could be opened by MySQL or something. You have these other definitions, utilities that comes with DBMS. They called database export and import. Database export and import and database backup and recovery that you do, snapshots, all those utilities are really good, because inside a database, sometimes you have a record in Microsoft Access. Now you want to migrate that one to MySQL, and Access is a relational database, and then MySQL is a relation database. And then sometimes you just want to import your data from one database and export it from one database and import it to the new database. So that's what the utility export and import comes from. And then and the examples of MySQL, it does have those utilities. So let's create this database. Inside this one, now it's asking us that we already created that one. Do you want to create a table? Notice that as soon as the nice thing about this interface is you don't have to know too much of SQL statements. You could do that one, but if you know it, it doesn't hurt you because there's options there on the query part of it. You could write create table, table name, and then all the inside right here it says create table. You could just say give it the table name. So notice that as soon as I say table one here, table one, it will just write that table one here. And then and this one is user defined. So whatever name I put on create table, let's say I call it a student, I could just name it however I wanted, lowercase, uppercase. The query language, SQL, does not care about the case sensitivity. But then there's option that you could check for upper or lowercase inside your records. So in this case, I could call it anything I want, a student, and then it will just create it. And then here, I could just have this option of adding fields. But adding fields, when I do that one right here, it will just add the field and say field name, the data type, and then the data type is, let's say, text or integer or number, whatever it is. That data type will be inserted, and based on that information, it will just add lines here to the number of fields that are defined. So at this time I named it this, I could add the first field and then say the first field is, let's say, student name. Let's call it first name. First name. And right here, you see that the field information, at this time, it is not knowing. By default, it says field one, but because I'm just going to change it to first name, this field one is going to change, and the data type is integer. At this time, I did not say that this is primary key or foreign key or anything, so I'm going to change the integer to a text. And then you see that it changed it to first name text. And now if I just say primary key, this is going to add in the constraint of primary key first name. So this is the query that is on the data definition language. Part of it is SQL or SQLite is making it so easy for you. You could just write it in this format, and then it already put it in the data definition language that you could take this information and put it into your Python script. So a lot of the people that they're working on Python programming language, maybe they are a very great Python programmer. Maybe they never work with a database. So if they use the SQLite or MySQL workbench environment, then they can just take advantage of some of these tools that provide you these queries, because you may forgot how the syntax of a primary key, foreign key was entered, how a table, if it exists, how you check for that one, if it, maybe you create synonyms, maybe you create an object, maybe you create an index. You may not have to memorize all of the different syntax, whether you're using inside the Oracle, inside MySQL or something. So these tools are written similar to the IDE. For example, we were using PyCharm. Inside PyCharm IDE, it gave you so many ways that you could do the development faster and better and easier because a lot of the functionality in modules, once you say import math modules or import MySQL.connector or SQLite module, any of those modules are there, and the Python charms, as soon as you say connect, it will already say what are supported under the connect method, what are the parameters. So you don't have to know a lot of it, but at the same time, if you know it, it doesn't hurt it. So you don't have to come here on this interface. You could just say create table, table. I'll show you those examples on the queries as well, if you know it. And notice that when I create this first name, at this time it's added this one and it says primary key. I could just say not null. So this one is gonna just add on right here, not null. So this syntax, whether you add it here or before the field, is defined at the time that the programmer or the person that who wrote the query language for it, and they come up with that standard. That's why sometimes SQL is called a standard query language. So once you learn the SQL statement, like I did, I didn't have to go to work on the SQL that I'm working on in Formix any different than Sybase or any different than MySQL or any different than Microsoft Access or now SQLite. I never used SQLite to begin with. Today or last week was the first time I looked at it. But because I'm familiar with the database, look how easy it is for me to teach this and how easy it is to cover the material. Those are the things that you want to learn once. You could use your code or reusable or the knowledge reusable. That's nice thing about it. So in this case, I'm creating first name. Now let's add another field called last name. And that's also text. So we could make that one also a primary key. Remember I was saying that the primary key is one or more record that makes a record unique in a database. One or more meaning one or more fields that is making. Sometimes the first name is not just going to be a primary key, and because a lot of students may have the same first name. And then now what if you have John Johnson or let's say John Doe or whatever the name is, that person may be in a different city, and then you have two person with the same name, right? So in this case, you have to add another field as the primary key as well. And then let's say call another field. This is also text, and then we say address. Address is also a text. We call it text because address could be a combination of numbers as well as text, but you could insert it as text, and then that is because it's combination of multiple keys. They're called composite key. Composite key is that when it is that the data is made up of more fields. Like for example, an address could be a building in a room. Address, for example, if you're restoring a server, the rack that is there, the address could be the building number, which is the data center. Inside the data center, you have a room where all the servers are hosted, and inside the room you have a rack, and then inside the rack you have the name of the rack numbers, and then all the servers location. So that information of location of a server is a composite key of multiple fields: a building number, room number, rack number, and finally the server property ID number that would make it. The primary property ID number could be in a unique record in the table as well. So at this time, let's say I created the address as this, and then I'm going to add the address also to be part of the primary key. Notice that as soon as you add those ones, the other fields that are first name and last name, I could say first name, last name cannot be null, right? So it adds those constraints, not null for these two. And then the next address field is primary key, and primary key in this case is for all three of them. This is the syntax to create that table with that information. Let's say we put one more course name. So let's call it course name. Course name, and then this one is, this time we just call it text as well. And then course name cannot be null, doesn't have to be primary key, not null. And mean not null. And then as soon as you do this one, it just added the course name as well. So now this definition is actually written in a way that right now I'm going to put it onto Notepad. Okay. So what you could do is, if you go to the data definition language part of it, this information is stored. Okay. You could just take this one and put it into a notepad, and then later on you could save it into your Python script as a creating table. Then now you have the information how you create this table. And if you create a second table, you could just do the student one and then change these fields. You know the data type that it supports is based on this field. So if you just look at a number of the data type that SQLite support is integer for accepting integer, text for storing any MySQL, and Oracle, they use a varchar. Varchar or var character, they have two types, varchar and varchar2. As I mentioned last week, the difference between varchar and varchar2, varchar2 supports basically storage, handles storage better. What I mean by that one, let's say I define first name and last name to be 15 characters, but first name is only John, that's only 4 characters. So what happened to the rest of 11 characters? Varchar will just allocate 15 character for John, and that will just have some kind of security issue as well. And the security issue is because on the SQL injection, when people are writing it, if you define a field that's supposed to take 15 characters, now somebody is knowing that, okay, my name is only John, maybe I could put some extra fields after that one, because the database allow it, and those other ones I could inject something that could cause corruption on the database, or delete something, or read some record or something that I'm not allowed to. But this kind of information, it is much better if you do, like for example, varchar, you're allocating the number of fields that are there. In that case, only 4 characters for John will be inserted, and then the rest of them is not going to be a blank space allocated for somebody to do some sort of SQL injection. So varchar2 does support it. And then on top of these ones, when you're doing primary key, foreign key relationship, and not null values, you're kind of blocking a lot of these other constraints that people may just later on try to find a loophole in your database to see how they could do some sort of SQL injection. There's a lot of built-in method that checks for these kind of issues, so you don't have any buffer overflow or SQL injection or cross-site scripting with certain things. And that's behind the knowledge, behind the scope of this class, because when we discuss introduction to Python programming, or introduction to programming concept and methodology, I need to give you the details of what you should be looking for, but the detail will be coming on your subsequent courses that you take, either Python 2 or Python 3, those intermediate and advanced classes, or if you're taking a C++ or Java++, Java, Java++. Maybe there would be someday Java++, but Java version or some other programming language that you do those ones, yes, there's intermediate and advanced courses that I want you to just explore, some on your own time or some maybe doing through your classes. So at this time, we know that there's another type called blob. Blob is for block objects that basically that they're objects, the files that are images and graphic and bitmaps and all those other ones. So sometimes you want to store the data as it is, and then you just want to pull it as it is. And those are binary files, binary large objects, and that's what blob stands for. And then there's real data type, which is in some programming language, you know that one as a floating point numbers, or which are real numbers that are having a decimal value as well as a floating point number, like 5.6 or 5.8 or 15.10, 15.10, 15.9. There's no 15.10 as 15 point, anything below 5 is, when you see that number, you sometimes round it off to a 15, and anything above 5 is rounded off to a 16. So 15.6 through 15.9 and 16 as rounded off. And then you have numeric values that you could have the numeric numbers. Any numbers could be numeric. Those are the definition of those ones. Don't get confused with that one. I was listening to one of the people that they were teaching on the internet, Python and MySQL, or Python and SQLite. I believe he was saying that a data type is not Boolean for that language. It is actually not null, and that is incorrect. Not null is a constraint, or a null is a constraint, not a data type. A data type on a programming language, yeah, Boolean is a data type that handles it, true or false. Boolean logic comes after the mathematician Boolean. Boolean algebra and Boolean logic was a very good concept that in programming languages and computer science, when you have a data type that is true or false, for example, say if tomorrow is Sunday, that becomes a statement that will, when it becomes tomorrow, you will determine, yes, it is there. But if you are, today is Saturday, you know that tomorrow is Sunday, that's also true. So true and false, if tomorrow is Sunday and tomorrow is sunny, we will play soccer. Let's say that to end the statement is a Boolean operator that it checks for the first case condition. If tomorrow is Sunday, then the and is a Boolean operator in this case that checks for second of condition, which is sunny. And then if those two, both of them are true, then it's going to be we're playing soccer. But if you say if tomorrow is Sunday or sunny, we will play soccer. Now the order statement versus and, this one of them becomes true, then we are going to play soccer. Whether it's sunny or it is Sunday, we will definitely play soccer. If both fails, then you don't play soccer. It is not Sunday and it's not sunny. So those are Boolean arithmetic matching, or Boolean algebra kind of is a big things. With Oracle, when I was doing my Oracle classes for both Bachelor of Science and Master of Science in Computer Science, when I was doing it, I had to take a lot of classes with Oracle. One of the class was called Distributed Database Management System. We were discussing Boolean algebra and a lot of other SQL stuff at the same time. But then later on, I taught some Oracle classes at Cal State Fullerton Extended Education Program. I taught at database classes at National University. I taught at DBMS. I taught at Computer Learning Center. But that was back in 1997 through 2003, I believe. I was working full time and I was teaching part time, one or two courses. I taught a lot of courses with C programming language back then, Visual Basic, compiler classes, operating system classes, Amazon class. Back then, when Amazon was still selling books, I was teaching e-commerce class at National University. The e-commerce class back then was everything was maybe HTML and then CS3, or maybe older version, nothing in terms of what we know now with Python and MySQL and internet being so robust that everybody has a wireless that they could just play with their phone and connect to the database and connect to Amazon Web Services and so on. But a lot of these the reason I'm mentioning those classes is because everything that it comes as a memory of what actually or these tools that are supported by different companies. Unfortunately, a lot of the companies that they build stuff, they don't give you everything in a way that it matches another vendor or another company that you already worked with. For example, if you're working on a Windows operating system, it's a lot different than a Linux operating system, and Linux is a lot different than Mac and Solaris or different OSs, VAC VMS, the old stuff of let's say IBM mainframes, and the new stuff of other Linux technologies. So a lot of the things that you learn it, whether you learn it in a small computing environment, like a local computer or a remote computer or a cloud computer, or maybe in a supercomputer environment, a lot of it it's similar, but it's not exact. So it's your job as a developer, as a programmer, as a sysadmin, as an engineer, as a software guy, to just come up with the differences and come up with a solution for it. You have to be solution oriented in your life, and much more easier to manage your life and other people's, and help them out when they need to. That's what a lot of these companies that they grow, like Amazon, Apple, and other ones, they just have that in mind all the time, to see how we can better serve the community. So in this way, case, I'm not going to create this field 5. So let's just say we delete this field, remove field, and that's there. So now we created that one. I'm going to just say, okay, go ahead, create it. So at this time, notice that this one is right here. It created the table and it has all the information. The data definition on language in this case, under the schema, it's already showing that inside that schema or that profile, I have this table called the student, and this is the data definition language part of it. That's how this table is defined. But at this time, I don't have any record inserted to it. And then, so if I just go to browse data, and then notice that this is a student, there's no record here, right? And then edit program. This is just doing it now. Notice this one is execute. So this is the part that I was telling you that allows you the option to just do it. So if I just was creating a table, let's say this one is called the student, right? I could just say inside here, say describe student. Let's see, the describe, for example, was saying some of it you already know because you did it on another language. So describe student, if I'm on MySQL, I could say describe student, I should get the definition of this. So this one, it says execute this command. Now, notice that this one does not have a describe syntax. But later on, I will show you the same syntax on the MySQL, for example, and then this option is there. And if it is not there, that doesn't bother me because I know that the table exists. And then I say, let's say, select a star from a student. There's no record here right now on it. So if I just run that one as empty, it just does not have any record. So how do I know that based on my definition here, I could just insert record. So since I know query, I don't need to go on the database here on the table and then say insert. I could do it a shorter form and do it that way, or I could just say, since these are my fields, first name, last name, address, and course name, there's 4 fields, I could just say insert. Notice that as soon as I type in that one, it's going to show N2, and then students, this is the table name, and then I could just say the field name here, I could just say first name, comma, last name, comma, address, comma, course name, like this, or could put 4 question mark here. The syntax for insert the statement, it says insert into this, and then you say values, and then inside the values you say first name is, let's say, John, and then last name is Doe, and then address is 123 Nowhere Street, and then address course name is, and let's say call it Fun 101. So John Doe wants to take this class Fun 101, which nobody is providing it, and he has no address. So that's fun. And at this time, if I just put a semicolon, or on MySQL, if you're having multiple statements, you have to do a semicolon to enter it. So let's say if I just insert this one to say this, let's see if it does a record. 1 row affected, so it already inserted that record. And then now, if I just want to run the same one, because I'm having a primary key foreign key relationship, this one should be not allowed by the DBMS, because we already created a primary key to have not allowed a duplicate record. So imagine if I just run this one again, right away it says unique constraint, field the student name, last name, first name. This one does not allow the thing. So all I have to do is that make this record unique. This time I'm going to come and say John 1 and Doe 1, and then the address, as long as one of these fields is going to be unique, I don't have to do the rest of them. Remember the definition of the primary key on a database is 1 or more fields. So this field is John 1, and then previous one was John. So the entire record is already unique with this one. So if I insert now, it's going to allow it. And then this time I'm going to say John 1, but if I just do it again, now watch, this one is not going to allow me. say that again. Now I'm going to make that one unique called do1. And then now it's going to be again allowed. Then if I just try it again, now I have John1 do1 at that address, so it's not going to allow me. Then I'm going to just say 1, 2, 3, 4. This address is different for there's John1 do1 on 1, 2, 3 address, and then 1, 2, 3, 4. So now it's going to just allow me to do it. I do it again, it's not going to allow me. Okay, so this one, if I just have this record, watch, because Fun 101 was not part of the course, I changed the whole thing. It's Sport 101. Let's say Sport 101, this one is not going to just allow it. It will not be allowed because this John1 do1 1, 2, 3, 4 already exists. So as a result, this field is not part of the primary key constraints. So in this case, this one will not be allowed. If I just run it again, it says Sport 101. I just missed something there. Let's see what is syntax error, Sport 101. Okay. Did I just, let me just, maybe it's hard to see that one, but the syntax is you put that one inside the field 101. Oh, I believe, let me try that, see what it says. Yeah, so it was just because of the bracket, somehow maybe I used double quote, and it's hard to see that one. It's too small for my eyes, so I corrected by just cleaning it up. But notice that this time it's, again, this Sport 101 is different than other ones, but this three fields that are part of the primary key constraint, they are going to be the same for John1 do1 at that address. So if I just make now change the one field of this one and call it John1 2 1 1, and then now it's going to insert it. Doesn't matter how many of which field of it that I want to do. So at this time, if I just say, okay, this one was good for insertion, I could put this one inside my record, and then let me just save this one as backup, save as. I'm gonna save it in the CS 12, and then SQLite, and just data definition language .SQL, just for that purpose. So you can just cut and paste that one later on for the class session that you guys could play around with it as well. So at this time, let's say I created this one now. I'm gonna just do some selection from that table again. And now, since the table is already there, I'm gonna do select a star from a student. That's as simple as the data manipulation part of it that you could do that select a statement. So notice that all the records are now showing that we inserted this one, okay? So now at this time, let's say we wanna just do a data manipulation language based on this one, or a data definition language. Let's go with the data definition language. I could say, rather than doing this table, I could do this table, okay? I could just say, since I have that one, let's call it, on my query, I could just say, create this table. I'm gonna just call it a student 2. This is a student 1 and a student 2. They're both table, or a student copy as a backup of the same table that is there. So I could just create this one. Now it created that one, but notice that this one is, let's say, select a star from a student. this one is going to return those number of records, but the student copy, because it's a copy of it, it should all have all the records as well. Let me see. Did I call it the student copy? Yeah. So that the record, the definition of this table is the same. The definition of the table is the same, but not the number of records. Okay. Watch this one. I'm going to go back here and then look at this one. The definition of the tables are the same, but not the value of it. So if I just say select this, it's not there. But now I'm going to drop that one, drop table student copy. It is not there anymore. Student copy. Let me just make sure I type in correctly. Student copy. That's correct typing. So that one dropped that table. It says one drop table, the student copy. It successfully committed. Now, if I go back to my definition on the database that I'm running, which is called new DB here, as you can see the name right here. Oops, sorry. As the name right here on the top. I cannot highlight it because it just does that. So this new db.SQLite is the name. Inside I have a table. But this time I'm going to try to create the table so I can copy similar to what the data is. At this time I'm going to not define it the way this one is, because this one is going to just create an empty empty table. So at this time I'm going to just say create table student copy as, and then I say select a star from a student. So by doing this, I'm just saying create this table, but this word as in SQL is telling me to create another this table based on the record that is on this table. All the field, everything will be copied. So I ran that one. I did not understand that this one. So on the SQLite, this definition of bracket is not understood. On MySQL, you would, or Oracle or other ones, you do that one. So remember, I was telling you that the definition might be a little bit different. So this is case it did not understand do the after as the bracket to say how you should pick up there. Now I'm going to just say as this one, and then this time it created it successfully. So I could just put this syntax also on this file. If you want to just create the table and import all the records, because maybe on the other table you have 1,000 or 1 million records. You don't want to just insert it manually, even though you could program it to insert it, but it's still much time consuming. And you could create views based on a table as well. So in this case, let me just do this. I have this browse data, and then now I'm gonna just say select a star from a student. This one will show me the number of records that are there. A student, from is the form. Okay, so you just run that one. It shows you these 5 fields, 5 records. No, sorry. When I'm saying fields versus rows, it is different. So fields are each individual field, like first name, last name, address, and CNAMEs. Those are also sometimes called tuples in relational database. Rows are called attributes. So this is longer, much longer. Actually, the other way around. Rows are tuples, and then fields or columns or attributes, because a tuple could have multiple fields. as you know, on your Python data structures, tuples, list, data dictionary, all of those ones are basically defined that have multiple words or multiple key pair value depending on whether you're talking about list and tuples or data dictionary, which is data dictionary is and database is a key pair value. And so in this case, we're going to do select a star from a student. Let's do select a star from a student copy. And that would also show you the 5 records. See, nothing changed. So now I'm going to say, show me unique record of it. Let's say if I say limit 1, the limit 1, or see how many records you want to fetch at one point. So on the database, when you write it, on the SQLite, there's commands like fetch all, fetch one, fetch many. Those are how you want to do it. And the SQL statement, you could do limit 1, limit 10, how many records you want to read at one point. So this is showing this. If I say limit 2, it will only show 2. Limit 3 is there. So limit 5 would show all of them. And then this would also show everything, all 5 of them. So at this time, I'm going to say a where clause, where first name is equal John. So I could say like that, John, John, and then run it, and then I will say this. If I say where first name is equal John 1, then it will just show those ones. And if first name and last name is equal Doe, notice that this might not pop up because it does, because there's a 1. But if I just change that one to a Doe 1, this is not going to be a record. Actually, we do have a record, John 1 and Doe 1. So let's say what other ones we have. If I just say where last name is equal, I want to see how many last name or John Doe 1. Okay, so we did that one. Okay, let's say where first name is equal John 11 and last name is Doe 1. That would make it, so what is, the where clause, you have to put it only once, that's true. Okay, so it picks up this one, but then I could say select a store order by first name. So that's another way you could query it for first name. If I put semicolon, let's see if it understood that one as well. Yeah, it does understand it. So normally on SQL, a line terminated by semicolon saying that I could do multiple commands at the same time. So I could put semicolon and I say select a star from student where let's say a C name is equal sport 101. Okay, there's a lot of different condition matching that you could do. At this time, look at this one, it shows the last one, but it ignored my first selected statement. And then in a query-based language, when you do it, multiple definition, it's not like this. It just show the first record, semicolon, the second one, as many query as you do, it will show it. Like your Python script, when you print a record or fetch some record and you print it, it's not going to just override the previous one. You could also use the where CNAME like. Let's see if I understood the like syntax. This is SQLite, that's why I'm checking these ones, but I know for a fact that MySQL and Oracle and other ones are supporting that. Where CNAME like what was the course name? Fun percentage. So that percentage is saying match the rest of them. Is it fun 101? Yeah, it does match it like this. So you could say where, um, let's say if last name like D percentage. So that would match all of them with the dough and print it out. Maybe the reason that this one is was not doing it, I could go on second line actually and do this one. Let me just do something like this. Select a star from um, a student where um, first name is equal John. Only that one, and um, I don't have to say a lot of n in this case. That's only unique with John. One record, I know that one. But let's see if it prints out this one first with all 5 of them, and then the second record like that. And then I could say, at this time, I'm going to just run those 2. Yeah, unfortunately, it just does not show the first record there. So let's see if there's an option here that would allow you to do edit program, maybe browse data. Okay, as you can see here, you can print the data that you're browsing. You can just go there. And if I just say, for example, on the SQL here, I could just say update something. So let's say update student set CNAME is equal soccer 101, and where CNAME is equal fun 101. So the update statement takes the name of the table, and then you set some value. You say set this field to this value where field is fun 101. That's the syntax in MySQL. Let's see if it works here. Yeah, it did. So now I just updated that one. So if I just look at the table where it says, let me just paste this information here too. So at this time, I'm going to say select a star from student. Notice that a student is way different than a student 1 now, because on a student 1, we have, a student is way different than a student copy. Even though we made a copy at that moment, the table, when you update one record, is not going to update the other table. It was just a snap in point at that moment when I made a copy. So if I have to do that one, I have to drop the table and recreate it to just match out at this time. That's why, and that at the time that when I did the copy, at that time it took a snapshot of what the table student contained. And this one, I'm doing select a star from a student, and notice that I could say where first name is equal John 11. That one is going to show me a sport 101, but if I just change the name of the table here to student copy, it's not going to show a student 101 because that is not a snap endpoint. So sport, actually, it does. Let me see it. Making a copy, because it was a copy of it with that data definition language, the DBMS is taking care of that one for us. Is that the case? Let me just double check that. Yeah, actually, whether you do it from there, since we did the data definition language of both of them are the same, create this table, student copy, first name. It is based on the other table. It just basically it manipulate the query the same way. So let me just do another update. Update this time a student copy as set. Let's say John first name set. First name is equal Wahid. Um, I could name it anything Wahid, and last name. I think you put last name is equal comma for the next one. Last name is equal Lutfi, and then field name. The first one I want to change it where comma C name is equal soccer 101. So I want to just do those two ones. No, actually, yeah. Let me just double check my update statement last time. I called it update with fun 101. Fun 101. And this one is still a sport 101. Yeah, actually, I was right in the first place. It was not allowing it, but let me double check that one with this statement. So update this one where an student name, first name is equal. Let's make the name of just John. John. So this time I'm just updating only John, this one, with my name and other information. Let's see if it does that. Okay, this comma might be a problem. Let me just take the comma out. Syntax error update. Okay, and try that. Last name. Where's my last name? First name Wahid. Syntax error. Last name update. Student copy set. First name Wahid. Okay. I'm gonna try to do another set here and another set here. So if that's redone, then that's fine. But some programming language doesn't support the set is not defined multiple times. Set, okay. Should have worked with commas. Okay. Okay, let me go to this one, edit, program. Close new table. Let's see. Edit, table view. Okay, at this time I'm gonna just do my update with only one field to see if it allows it. So I'm gonna just say don't do it with multiple fields and just change that. That worked last time. Update student copy set first name where student name is that. The multiple set or comma separated should have worked, but let me just try this. For sure it works in this way. And then now we updated the student copy from John to Wahid. So I'm gonna say select star from student, run it, and you see the student I did not modify it, so it's not there. So that select create copy that I was telling you that it's a snapshot of at that moment, I was right. So it was correct to say that. And then that second one, now I'm doing student copy because I modified it. The student copy is different and it has Wahid here. So if I say where first name, where address, and actually where last name is equal to the, and then if I say limit one, it's gonna just return the first record. But then in this case, if I just change this one to a student and limit one, now it says John. So that's different. That we know that one copy has the other one. Now we created a table. Now let's say drop the table. We say drop table student copy. So this is just going to drop that table and based on the definition that we created earlier, and now it dropped it. Now if I go back to the definition, the tables browser, or the actual structure, I only have the one. Now this time I'm gonna create another table based on this one, but at the same time I could just say create table, new table. I could call it whatever I want as, and then this time I'm gonna say select first name and then last name only. Last name from student. And then let's call this one another table. We say view, create a view, see if it creates a view. View one, first name or first name, last name. L, first name, last name. We create a view based on the two of those. Okay, so it created the view. Now if I just put this one, a view is a read-only status of the table. But normally, imagine that you have a table that has 1,000 records in it, and you just want to have a view of it based on a small portion of the actual data. So in this case, I created a subset of the fields, first name and last name, and then the other person, the certain users, you don't want to give him all the read access to your database. You want to say only this portion you should see, the other portion you're not seeing. So that's why it's called a view. You have a narrow view based on the criteria that you specified here. So I created this view FL for first name, last name, and then I'm going to just save this one here. And then now I say select a star from first name, last name as that one. And right there's the information that's there. So if I go back my definition, the edit program and this, notice this is under the view. I have a view, create view on this. It's really neat that they have all these tools, like you can see here, triggers. Triggers or another option that is stored procedures. Based on the stored procedure, you trigger certain functions to be spawned by the DBMS at certain time because some condition matched. Indices, like creating indexes. So at this time, we don't have any index. I could create an index here, say, let's say, create index, index 1 from on student, and then first name. If I just create that syntax, let's see if it supports that syntax. Yeah, it did. So the syntax is, this is similar to SQL, MySQL. Then it basically create an index. An index you created to do kind of like performance, for performance reason, you create an index. So you could just say, if this index is, if a first name is, let's say first name and last name maybe is index, or just first name is index, then it's much faster to return the record because you have a lot of John and then John 1, John 2, and other ones. And then when you create the index, it's just speed up the process. And then there's different type of algorithm for creating the index, whether they're binary tree search or they're kind of like hashing search or breadth first search, deep first search. Those are deeper in the code level that we could talk about. But at this time, let's just look at the index. I just created that index there. So I could just say, let me just put that one, create index is there. And this is just for your information. Later on, you could look at the syntax and play around with it. I'm putting that one into a flat file so I could put it into the canvas for you, and that you can play around with SQLite and learn more SQL as well as inside your Python script. You could cut and paste that code in the Python script later on. So let's go back here and then say select a star from index 1. Index 1, that's no such table. Yeah, this is index. So select from index. I don't think you could do this. Let me see how you retrieve the data on the index. Browse here. So right here, create index. So we have that one, and create table, create index, create modify index, print it. This is just actually printed to a printer. Tables, index, this is neat. Let me just make this one bigger. Okay, so this is my table, and then this is the data definition part of it. This is the actual fields, and then data type, and then whether it's a primary key or not. And then this one is the index. There's one index for it, and then the index name is first name, and then the schema, it's called first name also as this. And then I have a view, and that's just another kind of like, let me make it a little bit bigger so it's more readable. Yeah, I think it is readable, but 100% of it would be better. Yeah, now it's better. So this one is nice because this one is like a structure that tells you how this table or indices and views are defined. This is all the data definition part of it on that thing. Can I save this information? If I cannot save it, I'll save it like this. Okay, let me do save this one, snapshot, a snipping tool. I'm going to just say, open this and new. Okay, edit, file, save as. I'm gonna save this one also under the SQLite, just demo part of it. We call it data definition language. Um, model maybe, model, data model, data model. Okay, that's good enough. So I saved it for that purpose, and then we could also save this information. Let's see, I'm gonna close this, and right here, new database. I could save this information for you on the SQLite. I want to save this, some of this, because it is going to give you an easier way to just trace back to it. Okay, edit, copy, Word document. I'm gonna insert some of these records there. Later on, I'll post it for you so that way you have everything in a nice interface. You can refer to this lecture and you could walk yourself through it, or you could look at this document that I will post it later on, and you could get advantage of that. Let me cut and paste one more information here. This is that browse data. You could just get a snapshot of that. Gonna do only this portion, which is important in here. Edit, copy, and the next one I'm going to do is actually the new database. We did not create data structure. I want to make this window a little bit bigger. That way you have at least this information in a readable format, because the top portion of that information is not as readable. So this is a continuation of that. Let me save it. Sadina.edu, CI12, SQLite, and doc1. Doc1 is fine. We'll just name it doc1. And then inside here, we did the browse data, edit, and then SQL data. We have been running the command, so that's fine. And then for SQL data, I'm going to put this information, all of that, copy, and then put it here. Now you have an easy way to follow, even though I'm using a little bit of class time, But this is the nice thing about online teaching, that generating the notes that you could pick up on the class. If you were sitting in the class, I would write this on the board and you would take notes, and then you take that notes. But now I made that note for you so I can post it. Some of you did not attend synchronously with me, and they're logging in at another time asynchronously, and then they could still have a good picture of what we discussed by these topics, and then at the same time listen to the lecture. The lectures, most of the time, I'm making it much longer than the other ones because I want you to take advantage of what I'm teaching you as much as possible by providing you everything at the lab time, at the lecture time, and then you have the rest of the week you could use on your own time to add on to the lectures, lab assignment, and every other activity that are there for projects and midterms and finals, so you can work on it. But please make sure that for the assignments that were due already, most of you submitted it. I unfortunately don't have all the assignments submitted by all the students. A couple of students missed a number of assignments. A couple of students missed a few of them. A couple of students missed maybe one or some students, they never missed any assignment, any project, any. Those are always attending to the class as well as participating. So those class participation and project handling, all of that one is handled properly. So far, I want to make sure that you're keeping a record of where you are in the class by looking at your grades, the one that I have already graded. In the last projects, since last night I was seeing a few people maybe are not there yet, and then maybe 9 people out of 25 or 15 that were originally in the class that attended or submitted assignments. So please make sure that you're submitting it. It's better to have a few days late than not submitting it at all. Or even if it's a week late, I'm not going to count that one against you if I just either extended it for another week because of coronavirus, or I told you that I'm not going to count the late submission any issue as far as I extended it. But if you're not making the project, like for example, one of the project that I'm assigned last night, I assigned it a week from today. So that one has a solid date that has to be done because there's a second part of the project that is assigned a week from next Saturday. And then third one is a week from next third Saturday. So that kind of assignment, when it has a deadline that it has to be met, for example, if it's May 9, it has to be submitted by May 9. Today is 425, and for each assignment, at least you have 1 week to work on. Please make sure you complete them. And then if you have any questions, send me an email. Some of the students, unfortunately, they have from time to time some issue submitting the assignment. I already took care of that one. And that one was on the assignment number, the last assignment. Either was project or assignment 3 or something. But the ones that I want you to make sure you pay attention. If you listen to the lectures on Canvas, some of you originally on day 1 or day 2 of using Canvas had issue with listening to the views or in the Canvas, or listening to the actual videos of the lecture. And then a lot of you guys took care of it by just going to your browser, clearing the cache, and then logging into Zoom and accepting the options of on the client side when it says open Zoom, and then you accept from there you don't have to do much as long as you just follow the Zoom default kind of like setup environment for your client. But then on the subsequent video, when you watch it, if it asks you, prompt you for a password, most likely there is something on your system that you need to take care of. It's not none of these ones I define as password. So whenever it prompts me for actually when I create the Zoom video lectures, I created on the cloud. And so I could just post the documentation when it is the videos with all the transcript, everything online when it's available. When it is available, I cut and paste that URL from Zoom and then I put it. It does not make sense for 15 student to be able to view it, and then a couple of students have problems with it, either by not being able to view the view or the video, or they have some sort of password restriction. If you do that one, please make sure that you clear your cache on the browser, clean up, and then or use a different browser to see how that reacts. And if it is still not a browser issue, make sure you have internet access to the system. And if that is not there, make sure that your firewall on your system is not blocking any thing. All of a sudden, maybe your firewall is on the your ISP provider, and they just or asking for certain information. Any of those things is all on the client side. You could just reboot your machine and it comes back. And if you could look at that one video, the other video, and then the third video is a problem, you can send me an email and I'll definitely look at it. But if you're only unique, it's most likely on your side rather than every student is experiencing that one. If it is more than one student is experiencing something, maybe as on Confer Zoom or a Zoom website that we could look at and correct it. But if it is only one unique person, then please make sure that you watch what you're doing whenever you click on the lecture to listen to it, or the Canvas to log in. And if something went different, think of what was the last thing that caused this issue, what was the last update on your system that may have reflected that one. Okay, so it is 9:55. I cover enough on the SQLite instance here. Now we're going to go to do the same thing on Python with SQLite. Okay, so I'm going to open a command prompt first to see how the SQLite syntax and everything. And then at the same time, I'm going to do that options with PyCharm as well. So let's just do this. At this time, if I go to my Pasadena.edu and then go to CIS 12 and go to SQLite, this directory, I have a number of Python programs. So create table, for example, create employees and this and that. So inside here, there's that my.db and everything with SQLite should be there. Remember, one of the table was new DB that we created. This new DB is actually a database file. Notice that it's like 8 kilobytes. That one is pretty small for a database. That's why it's a SQLite. It's a light version of the database. If you do this one in MySQL, by default, or Oracle, by default, there's a lot of database file, DB file, log writer, control files. There's so much in it that it grows really huge. Inside of those tables, there's table spaces. I'm sorry, inside of the schema, you have table spaces. Inside the table spaces, you have tables, not the other way around. So at this time, I'm going to show you inside this one in the new DB SQLite is the file and the database, and let's call it new db.sqlite and look at the py script. Okay, so employee.py. Let's look at this first one. Say insert select student.py. Notepad ins select student .py. Student.py. So the name of the database, remember, is new DB that we want to work on today. So right here we created, and then here import SQLite is the first syntax, and then the next one is once you import it, then you use the method connect for SQLite. If you import this one as s, then you say s.connect. But if you just say import SQLite 3, then you have to say SQLite 3.connect. The connect is the method that you're connecting to the database. So if this database doesn't exist by default, as soon as you do this connect, it is just going to allow you to create this database on the directory that you are here. So in this case, I'm gonna just, let's just make a copy of this one. I'm gonna copy ins select and student.py, and I'm gonna just say the name of their database, newdb.py. Exactly as we define it right here, the name of the database. So inside here, I'm gonna just say newdb.sqlite is the name. So I'm gonna say notepad newdb.py, and then right here, and just say newdb.py. Okay, but at this time, since we already did that one, I'm not gonna recreate that one. I'm gonna say, this time I'm gonna say another database instance called newdb1. So we leave the database that we created on the SQLite here as it is. We're gonna just have another database as if like we're doing a new DB, okay? So if I just have that one, and then all my other lines, let me save this one. Okay. Exit. I'm gonna just copy new db.py to new db.py.back. For now, I'm just gonna create this one as a backup, so I could manipulate some part of it without commenting it and testing it to see what it happens here. So I'm going to say on the notepad that I have here, let's say I'm gonna leave this notepad here. At this time, I'm gonna say notepad new db.py. Okay, so at this time, I'm not gonna allow any of these statement, nothing, and then connection commit, and then close connection. I'm not gonna create cursor. So if I have this 3 statement at this time, I'm gonna just say create a database called newdb1.sqlite in my current directory, and then make a commit on it, Commit is saying that as soon as you do it, then close the connection, not close cursor, sorry, connect.close. Connect.close. So this connection will be closed, and as simple as that. Let's see what it says here. So if I just go on the browser side here, I could do it on two ways. I could show you Pasadena here, SQLite, CIS 012, and then SQLite. And I'm just going to create a new directory here called new. New. So at this time, I'm going to show you this screen that's empty right now here. And then I'm going to make a directory called new here. The new already existed there since I created. So I'm moving new db.py to the new directory. And then since it's DOS, I'm going to use that command. Now I cd to new directory. And here I only have two files. I'm sorry, I only have one file, new db, and that's the one, the Python script. So inside the Python script, I have new db.py. You can see that I'm importing SQLite 3, and I'm doing a connection to it. So at this time, if I just run that one, Python new db.py, this is how I'm going to run that module's new db with using Python. And notice that if I just do this, I'm gonna make the screen smaller here, and then have this window here. Notice that if this is successful, it should create right here, this directory, a new db1.sqlite, and by just doing that statement. Okay, and then that was successful. It just created that database here. If I go back here on my SQLite instance, and then I say, now look at the database, notice that new DB1 is also, new DB is there. Let me refresh this. I'm gonna just open up fresh. So save all that thing, and then say SQLite and browser, just open it up. Okay, so on this one, open database, and then now I should have a list of the database that I've created previously. And then under the Pasadena, let's see, this one is Wahid Lutfi. Where's Pasadena? Sometimes that's why I don't like the GUI interface. It's much slower than, so I'm gonna type in Pasadena here. P for Pasadena, and then go into here, Computer Information System 12, SQLite, and then inside SQLite we have the new directory. And right here, that's the database that basically we just created. It's empty right now, you can see. There's no tables, nothing, right? Table is 0 and everything. So I'm showing you this because you understand exactly what we're doing in Python and how we're creating. we just, by doing this statement here, we just created a database called new DB1, and then that's the new DB1 right here. New DB1.SQLite. It doesn't have any table, it doesn't have anything in there. So in order to do that one, I'm gonna just make move the new DB1 and dot back here. So move parent directory called new db.py dot back right here. So I just moved that file here. This time I'm gonna just move the new db.py to say new db.py dot alt. Doesn't matter what you name it, but I'm gonna rename this one as uh, uh, new db.py dot back as new db.py. So now I have this one with more information. I'm going to do a notepad on it. Let's see if that file is already open. I'm going to close this one because this one is the previous one. So it's gonna close that one, and then I'm gonna say notepad new db.py. Obviously, what I'm showing you with notepad, you could do inside Python interactively similar, and you could use, let's say, idle. You could use the IDE like PyCharm, and we will experiment those as well. But I'm just showing you from command line of this one with Notepad because it's easier for teaching to just not have too much of details by all these extra GUI and extra icons everywhere. So this is much more cleaner in terms of exactly what we're doing here. So in this case, I'm going to just remember the time. So we connected to this new DB. This one, if it already exists, it doesn't do much to it. Okay. Remember, I was correcting one thing on the con. This one is connection dot close, not cursor close. Cursor, yes, you open it and you fetch it and you close it at the end. But in this case, we're doing a con. So there's two type of syntax with Python. One way is that you open a resource. In this case, is a connection. Connection, when you open it, you're responsible to close it. Because Python does not, with this syntax, the way we open it, we did not tell Python that go ahead, close it for me, because we did not use the with statement. So in this case, we're coming back here and say close connection. And that's how that connection will be closed. So the file handle that you open to make connection to that new database 1.SQLite, it is closed there. But if you use the other syntax, which is the context manager of Python plays around and do it for you, with that one, instead of that saying connect here, you're just saying with, and then right here you say as con, and then you say this column. This syntax in the context manager take effect, and it says that since you're using this with, the context manager already knows that you're opening a connection, then you don't have to put this SQL commit there. Okay, so let's just play around with the first instance like we did in the past. We're going to open the connection and close it ourselves. Con is equal, and then SQLite. That's it, right here. At this time, we're opening a cursor. Why we want to open a cursor? Because a cursor is a way to manipulate the data definition language, data manipulation language, data control language. You open a cursor, is a buffer and, or a pointer to a buffer on the table space that you can manipulate tables, indices, and other stuff. So you create a cursor to point to a table space. In this case, a database that has no tables, no table spaces, no indices. So inside the table space, you have tables and indexes. And then in the SQLite, you don't have a table space. You have just tables. In the example of MySQL, every time you create a schema or profile, you have table space. But then inside table spaces, you have tables. And then you can shrink and grow table spaces based on how your tables are growing. At this time, let's just do create a connection. We did that, and connection SQLite 3. So I did the connection. I opened a cursor. The cursor is based on this connection. As soon as you say this connection is available, now you have a method called cursor. You open a cursor. With cursor, whatever you name it, my cursor, COR, whatever you name it, you have to use that one with their methods that are available. With a cursor, and now you have a method called execute. This execute method is basically taking one or more SQL statements inside some kind of like either document kind of three strings, or one if it's only one row. So if you're creating a data definition, you need to put it inside a document. And then you create, if it's one line, you could put it in a single quote like this, it's good enough. And it creates the table. Then you could fetch some record, like inserting records into the table, and then committing it, and then so on. So let's see. After you did manipulation of the data, you normally commit that one. Okay, you commit that one, and then this one you could commit the transaction here, and you're done with it. Then you could view it, do more records, and read from it, and so on. So let's see if we look at this data here, create table, insert. Okay, so we have this information, but we could use this statement that are already there. This time we're going to insert these records in there. Okay, so notice that this one has a different syntax, creating table from a student as select from a student one. This one, I'm creating table based on another table that are there. Let's see if we could do read from another even database. So the way you do that one is you could just say something like this. Let me say execute this. I'm gonna just say create table student as select new DB. So this is on the other directory there. I don't know if it restored the new DB like this. New DB dot SQLite dot student select star. This is the saying, this syntax, if this database is on a parent directory on Windows, I'm telling it to say create this table on the new directory here, but go one level up and find another database called that we used it earlier, DB. Let me just make sure the name of the other one is also new DB directory store.SQLite. The name is called newdb.sql. So newdb.sqlite, and then I need to just pick up this student. So this syntax, if it works on MySQL, would work as long as I'm just creating one table based on another table, which I will show you also. But let's see if this one is going to create that table. No, it did not. And it says syntax error, create table student um, as select the star from, select the star from, and this one, and let's see if it, no, the dot dot is not understood. So I'm going to just temporarily copy the other table here. Say copy new new DB. Let me see what is the table name. We call a new DB1 as ours. So I'm going to say copy dot new DB dot SQLite here. So now we have the previous one, new DB also. Notice our new DB is empty, and then the previous one that is here is there. So now I'm not going to just say new DB. Let's see if it can pick up from that one. Select star from new db.SQLite. So it should pick up that information, and unfortunately dot SQLite. The SQLite. Yeah, that's correct. Okay, so it doesn't see the cross this select table, create table student as select the star from DB. Let me just see while I'm here. I say select select the star from new DB, not new DB, from a new new db.SQLite. Student. Yeah, it doesn't see the previous table that way. So no, never mind, I could just create it on the fly, like we did here. So we did this one. Now I'm going to create the student table. And go to this other query right here, and okay, so let's put that one inside here. But because it has a more than one line, I'm going to put within a three bracket quotes, and right here I'm gonna just say insert that one. Okay, so this is create table with this and information is student, and then first name. Let's just have this, and I'm gonna move this one under this to a little bit have the, when you're using three codes, the format of this one is however you type it in with that space, it will be that as format, primary key, and then this. Okay, so this will create our table, a student. But now we have to insert record differently because that table has one more field than the other one had. We could just make our life easier and just create first name, last name, address, get rid of the address, um, and then use this information already there to populate the database. Yeah, I'm going to do that one. I'm not going to create the address in this case. So that's good enough. First name and then first name address is the primary key. So at this time, I'm going to say those two are the primary key, first name and last name. And then let's just add the CNAME also. CNAME. That would definitely make it a unique course name. So this is the new definition that we want to do for this one. I'm going to actually save it here, and this file is good enough. So at this time, we have this one. But then now we don't have to do this insert statement the way that we did it on there, because here insert into student, we have more than 4 fields. We have to define it 4 fields. And then these other ones we can play around afterward with this. So create a table student this. At this time, I'm going to say, go ahead, insert it into a student. The name of this table is a student. Let's just call it, doesn't matter the case sensitive, but it's better to have the same thing. So in this syntax that we are doing here, we're having placeholder for those fields. Oh, the student ID is there too. So that makes it unique. Okay, we could just say add another field here. We could just say a student ID. A student ID. And then integer. Integer. And then not null. And then at this time, we don't have to do anything on the primary key. We just say student ID is one of them. That's good enough because the student ID, these numbers are unique. So we don't have that many primary key as fields. Everything else, first name, last name, course name, could be duplicated, that's fine. But the student ID has to be a unique number. So this is better. And now we're having all the record being inserted. That part is done. Let's say after we insert these records, a student ID, we have a student ID, STID, okay. And then commit it. And we could have, instead of question mark, those fields, it would be better. Normally, it's a good practice not to have a placeholder. You could put the fields that you're inserting, less ambiguous, and it's more prone with question mark to SQL injection and other ones, depending on how much of the data type that allows what type of insertion and so on. So connection commit, we are committing it, then it prints it. Select the star from table where student ID is 1, so that would print it. For row and cursor, this is the cursor that we open, and so since the cursor is there, we print rows and it will print those records. Print the student 2. So now this was for student ID 1001, now we're printing where student name is student 2. And that will print that. And then track table work, clause order by place. This one, select title play from. This one is something else. We did not create that table. I'm just gonna comment that one out because on the previous session we did work on the track tables and the database that was already in that chapter that we covered. So now connection commit and then close it. The connection commit is done here. A data definition language, you do that when at the select statement, you don't need to do a commit. It's just basically automatically reading the data. So this is actually close. This is a commit because I'm modifying some record on the database. Whenever you do transaction, which is data definition language kind of manipulation, now you're defining a data or you're destroying or deleting the records or something, dropping tables, then you need to commit or roll back. But when you're doing select or insert, not insert, actually select the statement, then you're not doing any commit. At the end, you're closing it. So now let's say save this. And then the name of it is new DB. So notice here, I don't have any table yet on this database. And if I go to the this, it's just empty. So let's try to see if we are successfully gonna create that database. And right here, the database SQLite, you can see that the ours is new DB1, which is this one, is empty, 0 byte. And does not have any table 0. So I'm going to just create a student table with running this Python program star.py, and then new DB is the name, new DB. We already created the previous one with the table name, this one, so that the database name, the database already exists, which is this one right here, but it's empty. Now we're creating a table called the student with this field's name as data definition for it. And then the student ID is the primary key, so it will not allow duplicate record. And then here's the record that are inserted. And each record is a unique record because the student ID numbers are different. And then as they're inserted, then we do some select a statement where student ID is 1000 or select star from a student 2. This is student 2 actually does not exist. So this one is going to fail at this point when you run it. But up to this point, it's going to be successful. A student 2 does not exist yet because we're not creating that student 2 table. But we will do that one after. So let's just run it. We say Python new db.py. It did it. And now, as we expected, this table student 2 does not exist, so it failed. And let's see if the first one, if we refresh it, SQLite DB, there must be a way here to refresh it. So I go here, I go execute. Let's see if I could just say select star from student. Okay, so most likely this is empty. Select the star from student. A student is empty, 0 byte, but looks like the structure got created. Yeah, the structure got created because we just said that that's there, but the records are not inserted yet. And let's see why the records were not inserted yet. So notepad new what was it, new db.py, I believe. Yeah. So at this time I'm going to look to see why the insertion was not done. We did a commit here. Let's just comment out, actually not comment out, and then we say select print table 2, this. Okay. At this time, if we run this one again, it's going to fail because this table were already created. It's going to say this table already exists. Let me just do that first. I'm going to run this one again, and notice that it says a student already exists, which makes sense. So at this time, we're going to modify the script, and then it's going to say create table if not exists. Okay, so this one, let me put it all in uppercase like SQL, if not exists. This one, um, it will check if this is doesn't exist, then it will create it. If it is not existed, it will create it. But if it exists, it doesn't do much. It will not error out. It will try to insert the records there. Let's see if we just save this, exit out, and then run it again. This time it's going to fail on the student2 part. Python new DB there. Yeah, in student2, it says no such table because we have not instructed to create that table. That is understood. So let's go back here. And then here, if we go to the data definition and we say select a star from a student, it's still 0 empty because that commitment was not done because transaction is atomic. So since one failed and the other one was not done because the database does not want to be in an inconsistent state. So let's go try fixing the problem of a student, okay? There's two ways you can fix the problem of student two. Let's say I'm gonna go with Notepad here, opening it. One way is that don't just do anything with the student two yet because we haven't created anything. We could say search for student two, let's say. I want to make sure that I check for find, look for student two, and then find it. So here we're referring, inserting a record, and then here inserting a record name is student two, but table, this one it says insert to student two. This is student two doesn't exist, so this insert the statement failed. It could not insert into record there. And then the same thing here, the same thing here, same thing here, the print statement. All of those ones are going to fail because there's no such table. In order to fix that one, we could just create a duplicate entry using another query execute here, similar, and do it this way. And then right after each one of them, we're going to do a commit. Okay, in the first instant, because this one already succeeded, this if not exist is going to check for it, and since it exists, it's going to skip it. This one is going to say if it not exist, yes, it does not exist. Therefore, student two is going to be created. So we're creating this student two with same syntax. Another way we could do it is that syntax that we did earlier. We could say cursor dot execute, and then we say we could put one line because this one is not that format of going multiple lines. We could just say select a star from, I'm sorry, not start, create table student two as select star from a student. This is one line, but it is much easier to do it. And then Control C, and then do this. So now I have a choice of either commenting out the longer one, like this syntax, commenting all these lines, or commenting the shorter one. In this case, I'm going to choose to comment this one, and we will practice with that one after, and we did the first one to make sure that this one is working, and we're committing it and everything. So let's save this. And I'm going to exit out of this so you don't see anything extra. Here, this time I'm going to run the same Python script, say Python new db.py. And luckily, this time did not fail because both of our data definition language for create a student and a student table, both of them created, and then the records were also inserted. And then the record, since I picked up a particular information with the where clause, it just only shows this. So if I just go back to my, notice that the SQLite .db file, star.sqlite file, also has a more larger size now, because this is not empty. It has tables, inside tables, it has rows and records that are inserted. So here, I'm coming back to select the star from table, and then I go back here. You can see that this is there, but execute query. If I just do this one now, it's going to just show the records that are there. Since I did inside this one, I did a particular one. Let's say type in notepad new db.sqlite. I'm sorry, new db. Okay, so notepad new db.sqlite. Right here, where I'm doing the select statement. Wow, that's really not. Oh, sorry. That's why it was showing gibberish on that py, because you don't want to open a database that's a data file that was well, it was that kind of format. Normally a DBMS has a way to read those tables because it is written in C language or C++ or whatever language, Python, Perl, Java, that it is written, that language knows how to open the tables and how to manipulate it. Like in our case, for example, we are opening it with new db.py. We're reading the data that are inside of the database by making a connection to the SQLite instance, and then at that time I'm going to read the data. So let's try this new db.py, and then we call it sorry, new db.py. I'm thinking at the same time something else that I need to cover based on the time left. So let's see what I was showing you. Yeah, new db.py. I wanted to show you the where clause part of it. So in this case, if I say notepad new db.py and I open it, notepad new db.py. Okay, at this time, if I just open that one and I want to say, go ahead, insert some record, edit, and this time I'm going to comment out this section. And all of that section. And now you see the advantage of IDE or VI, BIM or something, how easy it is to just go on multiple lines. On Vim, for example, I could just say set num on, and then once you set it, then you could just say from this line on to this line on, modify the first character to pound, and that would already comment this one. In IDE, you could also on the PyCharm, you could modify it by selecting certain portion and comment them faster. But at this time, I'm gonna just do those two lines, and then instead of using a student, I'm gonna just say create a student 3. So this time I'm gonna do the same thing, and then where I'm referring to table student 2, I'm gonna modify that one to student 3. Table student 3, and then select the star from student 3. And then this time, and instead of picking up a particular one, I'm gonna say select the star from a student. Doesn't matter. And there, you could just say it. And then I'm going to also run this one. Actually, I'm already doing here. I didn't need to do that. So this time, what I'm showing you here, in addition to a student and a student 2, this create tables is going to create a student 3, and later on the record is going to be inserted. So where I'm inserting this time, I'm going to insert to student 3, and right here to 3, and the rest of them are all in the student. That's fine. So those two records are added to student 3, and then the name of the file, last name is student 2. I'm going to also insert this one, say student 3 as first name, is student 3 as last name, and then student 3 as first name, and then student 3 as last name, 3 as last name. But then their user ID and group ID, I'm sorry, not the user ID, group ID, the student ID is the same. So let's just save it. The reason I mentioned student ID and user ID and group ID, I was just teaching that are the Unix. So, okay, so we are back to this example. We're saving it, and we're gonna run it. Notice the name of the SQLite file. It is this much. As soon as we create another table, notice that new DB is going to grow. So Python new db.py is this size 24.8. After this is going to be larger. But now I have a typo. Select the star from a student. I did not close it. So I'm going to open back the notepad, and then go to that select the statement on line 49 and modify it. So line 49, where I have a select the statement, where did it go? Right here. Select a statement, select the star from a student, right here. And that was not commented. And any syntax errors, the nice thing about it is Python or other programming language, it tells you specific line number was the error, and then right here pointing to that right parentheses saying that you opened it, you did not close it. So I'm going to do that. I already did, and then now I'm going to run it. This time it run, and then now at this time it's coming out with another error. New DB line, student 1, student unique constraint field. So that is good, because within the record where we are inserting, there's some unique constraint that's failing within the student. So student ID, this record 1011 already existed there. We cannot have duplicate record on the same one, because we insert that record already on that table. So that record can have to be unique. If we fix that one, the next one that is going to go, whatever number is on that one is going to complain. So because every this, now if we change this one to, let's say 16, because that is going to be unique, it's going to complain on the 12, because on the student, we already have the 12. So let me run it one more time. That's the nice thing about the constraint for not being normalized. It is just going to say on the 112, it's going to complain. Student table student 3 already exists. In this case, this one, we did not say create that table. So let's correct that one. A lot of the times, whatever a statement you do based on that one, you have to say create table if not exists, and then the name of the student 3. And now let's see if after that one is gonna just bomb out on this. It should, because that is already in the database, and anomalies are constrained by the database. Up arrow with the other one, Python. Okay, so now this time it's saying most recent Python line 3 student last name unique constraint again. Like I was telling you, it's going to bomb out on 1012. Now we have to fix that one. Notepad. So this is a good way for learning that, okay, I'm just showing you this because you could see why the uniqueness constraint is actually taking effect. I'm gonna not modify these other ones. I want to show you that right after this, now it's gonna fail on 1013. And then after that one, I'll just modify it all for all of them. So Notepad, and then I'm gonna run it again. Now see it fails on 1013. A unique constraint failed a student ID. A student ID is the primary key because we define it as primary key as that, so it checks to make sure that has to be unique. And if that is not unique, then it's gonna fail. 18 and then 19 and then 20. This time it should not fail, but this record, if this one was already on a student 3, which is not, it should pass on and add that one and then work. If this one was inserted earlier in Python, because Python is an interpreter, this should have not been even tried because it failed on this one. So that's when you know it's a not compiled language versus interpreter language. That's a neat thing to know about. So now I'm gonna do, I'm gonna just run it. And this time it should work like it did. It just inserted, but because I'm picking up all the record, I wanna show you all the record that are there. And you can see the output is really cool. And then if you look at the number of databases here, student 1 and student 2 are showing. Those tables, student and student 2, student 3 are not showing yet, but it will show because that table is there. And then you see the browse data, it is just, we added all these data. So if we go like select the start from a student 3, and that table is there because we inserted some record, it's already going to show. And now if we go back here, the student 3 is also already there. Okay, so now if we just wanted to get rid of a table here, you could even on this database, what you're doing on the database. One other note that I'm showing you here, what you have learned with object-oriented programming, part of Python. Let's say if you have an employee record or a student record as an object, all you're doing is basically writing some method to read the same kind of data and then manipulate it there. And instead of doing like inside your insert statement, you might use the Python method to do it. But instead of having these values, let me show you the notepad. what's the name is new db.py. And instead of these values, the way you're inserting it here with these values, they could be coming from a method, which is a tuple of data. Notice that these are tuples because it's a field separated by comma and between these brackets. So you could define a tuple that has that student record, and then you just insert it inside here. You do that one. If you have a class that is defined with object-oriented, and then the instance is called student1, S1, for example, then S1 dot student ID is this. S1 dot student name is this. Student one dot is last name is that, and student one dot class name is that. So all it is those fields how you are getting it and reading it and inserting it. Let's say just I want to drop a record in a database. So I could just simply do this, copy new db.py and say drop table student.py, just to make more student3.py. Just to make it more descriptive, I did this one so you know, for example, when you run this one, how to do it. Now I'm going to say notepad and drop underscore table underscore student3.py. And then all I'm doing is here, I don't need to create anymore. I could just modify one of these table syntax to say like this, drop table student3, student3. And then since I'm doing it within one line code, I could just close it here, and then I'm done with it. This other lines, I could get rid of it. And then here, I don't need to fetch any record. I don't need to do any insert, anything. I could delete all of that and delete all of this and close. So at this time, this is as simple as that. You connect to the database, you open a cursor, you execute the drop table on the student3, and then close this one, and then single quote. Notice on Python, when you do start with single quote, you have to close single quote. If you're doing this one within double quote, you could do that one, or you could just say student3, that's also understood. The reason you put it within two string, like a quotation mark, is just because if the string has spaces in between. So you don't, like for example, some directory name like program space files, something like that, and then you want to make sure that it knows that it is there. Sometimes you could backspace that one with, escape it with backspace, but sometimes you could just put it within code that will understand it. So in this case, I'm saying drop table student3 because there's no two-word character here, two-word string here. It's just one string, and I could put it in that syntax. That's as easy. So I'm going to commit my execution of cursor and then close my connection. That's as short or 4 lines codes to just connect to the database, drop that table student3. So notice the student3 is here. Now I'm gonna just go ahead delete it. And just by doing Python drop underscore table underscore student3 .py, it will just drop it, and now it will just disappear from here. Notice it's a little bit slow because the SQLite is trying to just execute that one afterward, So now if I just run this statement, it's going to say that table doesn't exist. That's good. So now it did work, and it now table 3 is gone. And the size of the SQLite the database file itself is also based on the number of tables that are there. Now it is smaller than before when it was table 3 was there. Let me see what table 3, we did not do an insertion. I want to just run that line of code again, and it's going to fail again. New db.py. And then if I just look at this contents of new db.py, notice that I told you that it's going to fail. The reason it's going to fail is because that size, what is showing, it's not accurate with the insert statement, because the insert statement are not unique anymore. Okay, so if I just run it, let's say Python new db.py, right away the first insert statement is going to fail. And that's the first insert statement, 1016 is there. So I'm going to modify this one, notepad student, let's say it's a new db.py. I want to show you two things by doing this, is that I'm going to just get rid of, let's just make another code temporary, okay? Rather than doing this one, I'm going to just say copy new db1. This is another easy way to do, use the OS as your friend to just create on the fly something, and then easier for your development environment to just create something temporary, notepad and new db1.py, and then manipulate it after. So in this time, all these insert statement, I only want to insert one record, and just change this one to say 21. Since that one is unique, it will allow it. And then I want to at this time create table 3 also on this one. So now I created this one called type new db1.py. Notice that all the other lines are the same except the insert statement. I'm only inserting this record 21, student ID with 1021. So if I just run that one and say Python, this is gonna insert it. Notice my previous tables are there. Table 3 is already created also, and then the 1021 is. So now the size of the SQLite file .SQLite file is not the size that it was there. 24.8. It is still there with the same size. Okay, so sometimes what happens is that it's because of a number of blocks that are there, that much of adding one line on a table, it did not change anything. So in this case, I'm going to prove that this is actually the case. Let's see if I can prove that. I'm going to insert some more record here. This one, I'm going to add more storage to my system. I could do that one, or I could just change this one, putting in a for statement, okay, and then insert all of that one to the record there. Let's just change it for temporary here to see what happened as a manual insert. 4, and then 5. So those are the ones that I want to insert. And this one was already there, so I'm going to make that one 26. And then run this MyDB one. Okay, 1023 was already there, yes. And why did I name that on 1023? So 27 and 28, 29, 30, and 31. Let's try that. Okay, we're inserting more records. Yeah, it inserted all that record. Now let's look at the SQLite example. The size is still the same. So I'm going to do a for statement and try to do a bigger list. Committed. Okay, we are going to insert the record of student 1. Let's see if student 1 here on the browse is growing. Yes, and data, and then SQL. Okay, student 3 is there. Yes, and then how about the size now? Is it still the same size? Yes, still the same size. I'm going to insert maybe 1000 record or something to see if it may, or 100 records to do that. Let's try 100 records. So here, how do I do for I is equal to this? I could say a while statement, say while number student ID is SID, while SID is less than 1000, less than 1000, begin. Since this one is a while statement, we're gonna do while this is the case. 1, 2, 3, 4. So this one is already there with the record. Let's say student ID is equal. I'm going to call it 2000. 2000. So it makes it 3000 at the end. Right here, as we go, we say insert a student ID as one record, and then here we say student ID plus equal 1. So that will just increment the 2000 to 2001 and so on. So let's see if that one is there. And then the connect as we go has to be committed there. We can commit it at the end once, that would do it the same thing. Let's try to do it commit only once. That way there's not too much of a record manipulation, but we will look at that one to see how the commit is done. So which table is this one? New DB1. So in this case, I'm gonna say Python new DB1. It is recorded, but 1031. So what happened there? The records 2000 is not showing. Student ID connect. Let's see one thing here. I'm gonna do a commit here and then try to insert it again. It should say record already exists if it does. So why, which one I'm define new DB1. Oh, student ID is, this is not less than, that's why. If a student ID is greater than 3,000, less than 3,000, that condition, the while statement has to be true in order to execute this statement. 2,000 was less than 1,000, so it's not there. So we're going to do from 2,000 to 3,000 and then stop at 3,000. And now that is going better, 3,000, and then we do it. Now it's just inserting, it's taking a while to see if it fetch that many record, 1,000 record is gonna slow down the database. But because of this unique primary numbers, it is still should be good enough to just grow it. Let's see, while this one is done, we look at the database to see if we're seeing some record here for student. Student, we're inserting into a student, I believe. So I'm going to look at here and say, select the star from student. This time, database locked. Okay, this is nice thing about the database DBMS management system. So the lock is sometimes as exclusive lock, sometimes as shared lock. With the database, in this case, is exclusive lock because all the tables that are being inserted, you cannot query at the same time because on the database concept, there's a terminology and that I could have covered. It's called dirty read and dirty write. Since the data is not committed, what we are reading is not allowed to be seen at this time. That's why the database lock is putting a lock on those table because it's inserting all these records. So it is still manipulating the 1,000 record. It might take a while to just insert that many records. I could have done 100 just to show it. That would have been better, but I could just experiment, and that's what this is all about, to see how fast it is and how efficient it is with a PC like this that has enough memory and 1,000 records. Can you add it without any issue or not? So let's see. At this time, the record is already there, so I cannot do queries. And I can tell also right here because my Python script is working on it. Yeah. Okay, one other thing you could do is open another command prompt here and look at the SQLite directory. Let me go to that directory plus dina.edu. Let's look at CIS and 12, and then SQLite 3 cd to new. The SQLite, this is still the same size so far. It is not showing yet because nothing is committed yet to say that it is done. This record, I could control C out of it and I'll start with a smaller subset to insert and check it out. It's good practice to check with a smaller subset first to make sure that it doesn't bomb out. This is development, so you can practice and feel how it is going to be handled on their resource that you have. But on a production machine, you don't want to do this kind of work. What you want to do is on the production system, you first find out your source and then how much the database can handle at one time, and fetching records and inserting records, and how fast it is, what kind of time constraint that you have on your business, and what kind of development time that you are allocating for it. So based on those criteria, you just filter out the parameters that are passed on. In this case, I could stop it if it takes a little bit longer than this. Then we could just go back to the original script and modify it. But if it is still going to be in that state for a long time, since 1000 record might be too big for the SQLite, and that's why it's called light, right? So I'm going to Control C out of it and just see as it Control C out of it, it is inserting and it is done. Basically, it's actually it was doing it all this time, and it did add it. So the size of the SQLite is still showing as of this same data, but I guarantee that it's gonna go bigger. Is that no? Maybe new DB1. I was looking at the wrong database file. This is not the full file. The one that we are working on is the new DB1, which is as of 11:10. You can see it was modified. So that is bigger. And now just to say that we did that successfully, I'm gonna just modify this one and say the size is start from 3000 and then go to 3300, 3100 up to, like, only add another 100 record. This is going to be faster than the previous one. And maybe even I could do it 350, 350. 350 records, 50 more records will be added, starting with record 3000. So let's just do that one. Good thing that the SQLite handled it. The reason I'm doing another 50 is to show you this size. This is the file that I should have been looking at. And then look at the timestamp 11:10. If I run the same Python script here, 50 of them, it's going to go and display 50 more in addition to other 3000 records when it is doing it. Look, it is doing it, but then now it starts with showing 3000 through 3049 or 50. Yeah, 49 right here. So 3000 is showing there. And then the size of the DB, new DB1, new DB1.SQLite is different, 57,344 and 57,344. And prior to that one, it was originally was 0 as we see it. And then prior to that one, prior to this, insert the statement. Let's see what it was. Yeah, new DB1, you see it was smaller prior to adding the 2000. So it is just changing. And then the timestamp was 1013. Now the timestamp should have another date, 1114, which was like last minute. So that tells you that the record is being inserted, and this database is growing. So now if I just run the same student table, it was saying locked, no longer locked. The lock is released, and then therefore it shows the record. But notice that now I have all the records. And I could also do like a count here, select count, and then put a star to see how many records are on my table. Total count, I just get a count of it, 1067. 1067 records on that table. So some of these query statement, you don't need to know all of them. If you just saw it on the screen and you did not see it on the transcript portion of it or the notepad, this is not a SQL class. This is a Python class, and that's why we're doing more Python than any other thing. But as I'm covering, let's say, CSS for cascaded style sheet or HTML, or SQLite or MySQL, I want to make sure that you have a good understanding of what I'm covering and what you need to understand. And the rest of them is as you practice, it just comes out with better understanding as you spend more time on it. So I think it's good enough for SQLite and Python to stop here. And I could go on with MySQL. I did not use any break, and some of you guys, if you are or girls that are participating, sorry about that time that I'm just keep talking, but I'm sure you're enjoying as I do, because this is good learning to just finish something without any kind of gaps in between that you come back and you say, what you were talking about? So at this time, I'm going to take a quick 10-minute break. You should too. And then we come back. I'm going to pause the video. We discuss MySQL. Okay? So let's just take a quick 10-minute break. I'm going to pause it. Does anybody have any question? Okay, let me pause the video. Pause record. Okay, we're resuming the recording. So at this time, we're going to just discuss further with MySQL and Python. We discussed enough for SQLite, and then I'm going to be allocating one more session for Python with SQLite and MySQL, so I could cover the memory-based SQLite information as well as whatever we need to cover for MySQL with Python. But today I'm going to just right now cover as much as possible with MySQL for this session, and then we stop for that one, and then we continue on the next session, a continuation of this. Knowing Python in a database, it's going to be really cool for you for any job that you're working on. And there's a lot of demand for a structured query language or MySQL development as well as Python development. A lot of the data science work that you do, you could be manipulating data with statistics software like they used to use R language or maybe MATLAB or any other tools that they have for it. But at the same time, you could use C++, Java, Python, and other ones. But Python in this class could give you that kind of advantage that you could use in a very simple way of writing programs to do a more readable, more kind of intuitive matching natural language. You're telling it similar to like SQLite. You just saw so many examples of how you could manipulate the database objects without worrying about, oh, I don't know anything about the database. How am I going to manipulate that table? How am I going to create index out? What is a primary key? What is foreign key? All that information is hidden. It's transparent. If you know it, it's great. You can work with it. If you don't know it, it's still, they have an interface. You can do it. So with MySQL, what I did on the for this class, I teach. I'm sorry. For this class, I installed a MySQL server on my Windows machine. So in opposed to the SQLite, MySQL is basically it's a full version of a database. It has a lot more tools than just a SQLite, a small version of SQL. So with MySQL, it is also a product that is people, even though it was open source, MySQL was originally was built in for small to medium sized databases, in opposed to like Oracle, which is for bigger databases, that data warehouses, the data that are much larger. Microsoft SQL Server and MySQL, on the other hand, are for medium-sized to smaller databases. But MySQL was kind of like uh, developer tools because it was open source. It was freeware, so it is based on GNU kind of licensing. It was free. MySQL company that was built in at the time that they come up, a lot of the developers were running it on Linux environment or Solaris or Unix environment, and Mac, and then they imported on Windows. They have it everywhere. Then MySQL company was bought by Oracle. Now Oracle, in addition to having Oracle, MySQL is also on the smaller to medium-sized businesses. They have MySQL database that they have customer for it. So the software is free to download. There's a community version of it. If you go to mysql.com and then you go to MySQL community download, you see that your URL is changing to dev.mysql.com, which is a development version. And then it tells you that this community version is free. It's free for you to download, play around with it, and create tables, create schemas, create table spaces, users, anything you want. And then at the same time, manipulate data. And then there's a developer workbench also that comes with the developer instance for it. So when you install it, basically you go to mysql.com site and you go to the community portion of it. So let me just go to MySQL database website. So if I go to mysql.com site, it's going to take me to the MySQL Oracle database site. It comes out with this, and then you have this download page. So if I click on the download page, then you have an enterprise version of it that you could do it for your companies, and then they have MySQL database, storage, connection, routers, MySQL shell, and there's all kind of like enterprise edition for MySQL that customer download and for companies that they use it. MySQL is basically about 60 or 70% of the databases in the world that are running on MySQL or MariaDB or PostgreSQL or some other one. But MySQL is the biggest one. NuDB and all those other ones that are coming. Solar, which is another indexing search engine that is not, it's called NoSQL. It's, Solar is the one that I used a lot extensively for some projects. And that is also good. There's also databases that you could do, hierarchical databases. So they are not having relationship like MySQL, that a primary key, foreign key relationship. They are not there. Hierarchical databases, an example of it is LDAP, Lightweight Directory Access Protocol. And then you have other database, object-oriented database, or that every thing is based on objects. When we go to Python, if you look at a class, when you define a class, it says class is this type of, the type is a class. So if you have a student class, a student would be a type of class. But then if you look at the data types like a string, integer, numbers, all those other ones, they're also called class. But then if a class has a method, then it's not going to show class of that file name. It says class file name and then the function name, and then it's a method. So that data type of those ones are all available at all time. At this time, I'm going to show you how to download the community version. So don't look here, look for here, MySQL community uh, general public license, GPL. JPL, I'm sorry, GPL, in this case is general public license. I say JPL because I work for JPL. It's really nice, Jet Propulsion Laboratory. But this is GPL, which is general public license. And this is a public license that they give it for the community so people could grow on their development environment. And then at the same time, MySQL will benefit from it because the more student, the more users are using it, the more developers are using it. They will go for some company says, why don't you install MySQL? In this case, we could have a database to do this. And then notice that you have everything like connector for Python, connector for object database connectivity, for Node.js, for Net, for J, for J++, so it was a replacement for .NET at the one point that Microsoft didn't want to install Java in a Windows environment, and they wanted to have their own version of Microsoft J++. Maybe this J is that, but maybe it's another J. I don't know for sure. But SQL, C++ is for sure is the C++ environment that you guys are using. So we are going to download the MySQL database here, and then they have MySQL YAM repository. So if you're on a Linux machine, you could do it. The one that we are interested in, MySQL installer Windows. Well, let me just see under YAM repository what they have. So under this one, they have it for Red Hat repository, for Fedora, and so if it has for Red Hat RPM, which is Red Hat Package Manager, you see this RPM, those ones are going to also work on CentOS and Fedora and other ones, but they have for different version, different ones over them. So that's why if you're doing MySQL server community, you need to download this one as a CentOS RPM for CentOS, which I do it next week for you guys. And then we could use Unix machine, in this case CentOS 7 as a installation, and we could do Python with MySQL inside there. So you have a Windows today, and then next week we do the other one as well. So this is where we have, and the reason I'm showing you today that some of you guys might have already installed the VirtualBox VM of CentOS, Ubuntu, or Solaris based on my previous discussion that I showed you how to download the VirtualBox and then how to build a VM on the, there's videos that I also posted. So you could even do that one and then be ahead of the class and do this one as well. But if you are behind and then you want to follow the class, you could just do the Windows installation, MySQL installer. And then right here, there's 32-bit and 64-bit. But because this one is, both of them is showing 32-bit, you could just download one of them. And then the difference between these two, and one of them it says x86 32-bit MySQL web community, and then this one is installer community. So I would have done the second one, installer community, because the web community is that for web-based, unlike maybe if you're writing .NET, you would write ASP, Advanced Server Pages. And if you're working with the Java, you might write JSP, Java Server Pages. And if you're doing Python, you could do anything. Whether you want to do web-based or this installer community, web-based also have the Java server pages as well as classes that you could just do more kind of uh, web options for JSP connection like servlet and containers. There's a web server that on top of Apache, you could be running like a Tomcat container that does a lot of um, coding with containers, containerizing JSP and servlets if you're interested in doing it in Java. But let's say you did this. At this time, you downloaded this one, which I did already. So I'm going to go to my CMD directory here to show you what happens when you do this. This Windows download, this is says MySQL something. So if I go to my downloads directory, most likely there's a MySQL that I downloaded, this one, MySQL installer community. Like I told you that this is the community version. You download this one, then you run this one. When you run this one, it's a Microsoft installer. There's a software in Microsoft that I used to work on and do some more coding on it. It's called Install Shield. This is .msi is the Microsoft installer. It has Install Shield syntax in it. It will just install it for you based on your resources that are on the system. So once you run this one, you could install it, and that's what I did. So I am going to show you this file, which I have already opened, and it's right here. Just to make this screen a little bit bigger, I'm going to click here. Okay, this is the site that I went there, and then after that one, community, I downloaded, and once I downloaded it, by default, when you go to the installation, it's gonna just say install the developer section of it. You could do full, which I did, and if the full does not work because some of the, let's say, Visual Studio libraries are missing or something, you just have to look at your machine and install those ones with other options and get it done. And then I would choose the default developer edition. Just choose the default developer edition. I'm going to show you, and I'm going to cut and paste the part that I want you to experiment from this one because I did a lot of other things that I wanted to see. Okay, so right here, like default is the default one. What page is this one? Let me see the page number. Insert. Break. Okay, just inserted a page break. I wanted to insert page number. Let me see, where is that? And every version of Windows, they move things around on, and these ones, insert page, blank pages, pages. Shoot, I can't seem to find it. Let me just undo this screen and say insert, customize ribbon. Okay, so where's the table? Insert for the page number right here. So insert page number, add page number, and so insert page number, page number, insert page number. Insert, remove number, insert page number, go to insert page number. If you don't have it, skip. Yes, I just did that. Let me just go back here. Insert page number. Number of your page. You can do. Tell me more. I just want to insert page number. That's as simple as that. Okay, top page. Okay, now I could say I'm going to insert on the bottom of the page for each page. And then page number. Slow, maybe that's what it is. So I'm going to just say plain number pages. So I'm going to do plain number. Okay. So that is showing the page number. I'm going to save this information. Save. This one on this PC. And then save it. Okay. So in this case, on the where it says that line number of the that one, it starts with the developer section. I'm going to do the developer section. Don't like all these extra information that are displayed on the top. You can hide it, but at this time it's just tedious to look. Let me just see if I could just go to that section where full version. Okay, so the next one that I'm doing is right here. Yeah, this is developer version. So all I need to do is the line number here, line number 10. Starting line number 10, I could make another record here to show you a step by step. So you choose the type, which is developer, and then you have to select how you want to install it. All these components that are there, the product part of it, it shows. So Microsoft Visual C++ is required for distribution, because based on what you're doing later on, this connectors that you say import MySQL connector, some of these ones, if it has those kind of component downloaded, then it's going to work out of the box when you work on it. Like SQLite was part of the standard modules that comes with Python that supports it. We didn't have to do much, but just say import SQLite. Okay. In our case, maybe on MySQL will not be much either, because I already did some of the extra work that I could have done ahead of time. But when you do this one, so if this component failed, don't worry about it. Just go to the next level, and then later on, if you need that one, you can install it. So it will just go through the installation, and then you click sometime next, sometimes say execute to execute the component. If you see the button execute, make sure you do the execute. And then right here, it is going to prompt you for users. So by default, a system that it comes in as a root user, you could add on more user, and these are your schema. So MySQL user, I just created one, and I put the password there, and then the password, if it is strong, it supports you better, but it's good to just have password that are there. But since this is development, I could even give you the password. It's not a problem, because I could just later on modify it. And if you want to just say, oh, how come, Professor, this one is a password that you put it on a video and you record it, now everybody knows the password. Yes, but this database will not be online. So a secure system is when nothing is up and running, right? Can you just log into a machine that is down, power down? It is doesn't matter what people know about it if it is not going to be online. So this is just a laptop connection, and it's not going to be online. And then I modify it afterward, the password anyway. So it's safe. Don't feel like, oh, the professor does not know any security, or this instructor does not know any security. No, I know a lot about security, and I know how to secure systems that are in production in really great companies. There's a lot of things I could show you with SQL and programming languages and operating system. More than anybody else on the topic of security and system level integration and configuration and everything, whether it's supercomputing environment, cloud computing, Amazon Web Services, local machines, and you name it. I have worked on about maybe 27 years or more on the programming computing environment, plus degrees, plus taking courses, taking certification courses. So I could feel comfortable enough to just say, no, this one is safe to do and this one is not. Not being cocky about anything, but I'm just telling you that sometimes people may just judge you based on what you said on a video or a class or something at that moment, and they don't know the detail of the next session that you are showing to the student or to that topic what you're discussing later. So this one is doing the installation, and when the installation is completed, of course this is installation and that typo. So I'm going to save it again. And once it's done, then you could play around with it, which I'm going to show you the actual play around. So this one, if you want to do server only installation, and then at this time, you can see some of the component that I'm installing, like Microsoft Visual C++. These kind of things, it will just prompt you. If your system needs it, you need to install it. If you need it to use it, you need to install those modules. Those are integration part of the libraries that you need later on for your system. And if something later on doesn't work, maybe you're missing a component, you need to install that component. And if the component is not there, then when you're doing a Python MySQL connector, then maybe on the virtual environment of Python, you need to just allow that to be available. And I'll show you that one inside the PyCharm ID. So SQL Server, this one is still through the installation for the SQL Server only. And it tells you, like, for example, when you do a standalone server versus InnoDB, sometimes you have InnoDB as like a cluster of databases. So when you have a cluster of database, it's for redundancy, for high availability. You want to make sure, if you're Bank of America, you don't want to see that if something happened, all of a sudden nobody in the East could look at the record, because God forbid a earthquake happened that it caused one data center that is down, then data is already replicated. So the transaction is atomic, those kind of concept. It helps us to just make sure that data is replicated as soon as it needs to be done. So install MySQL installer. Let me move a little bit faster. In this one, MySQL user account. So I was just creating a dev user account to play around with another account rather than root account. You could add on like using this add user. So you could create your own temporary. Here's the difference between you can create your own temporary account. That's what I meant. Here's the difference between MySQL versus SQLite. In SQLite, you notice that when we connect, we just give the name of the database. We did not give the host name. We did not give an IP address. You did a username. We did not give a password. The connecting string that you pass on to Oracle instance or to MySQL instance, or much different than a SQLite. So a SQLite did not have a user that we log in. You just are either working on a memory or on a database SQLite file, and automatically you're connected as soon as you create it. You're the owner. But in here, if I don't have those data control language of grant and revoke privileges, giving me select and insert and update a statement or connect a statement with cascaded option maybe, or maybe none, those privilege are only given by root or database administrator. So the data administrator has by default much higher privilege than the DB operator. And then the DB operator might be a power user, but not a database administrator. And then similar to like a Unix operating system, you have a root administrator and then you have a sudo access. With sudo access, you could define a particular user to have one or more privilege. For example, they could shut down the system, they could power it on, or maybe they could just add users, but they could not shut down and power on the system. So that kind of privilege, you can give it to a sudo access. And if you gave sudo with all access, then sudo is equivalent to a root access. And here the same thing. If you just gave all the privileges that database administrator has, and including granting other users rights, and then that user is not just power user, it's a DB administrator there. So by creating this one, as you know that on MySQL, there's kind of like different level of controls, and then that's based on the schema that you create. Inside the schema, you have now table spaces that you could say, this user could have access to table space 1, but not access to table space 2, or could delete drop tables or create tables, but maybe not create indices or something. So you could just control that. And see, this is really huge. I also did some Python scripting testing with this to see how it worked with each accounts. So this one is just showing that in the when you're running it on the control panel, if it is Windows, under control panel, you have under services, you have MySQL database instances. So this is control panel, and then look at the system security user account. Under services, let's see, administrative tools, and then services right here. And so these are all the services that are running on my Windows 10 server. And then the Windows services, as you can see, it is something related to MySQL. Let me close these other window. Right here, MySQL. The name is MySQL. So if I sort it out by name here, and then look for a MySQL, M for MySQL, right here, MySQL DB, it's running. So as you can see, it is saying it's running in automatic state. You can check it on the command line also if you're going in the PowerShell and then your PS stat and then find a process. I could show you all of that one, but at this time, this is maybe some other day we could just do on the next level. At this time, I want to show you how you or daemons is running and how you started by the system. It says that it's started already, and since it's automatic, as soon as I start my system, this will instant will be up and running, and that's why it says running. I could stop it if I want to, but I don't want to. At this time, it's running in a state, so that means I can connect to that instance there. And then in order to do that one, so it's running on the control panel, you just say, okay, my installation was done successful. And then right here, you can see the directory that I'm going there. You could even do this MySQL.exec and then get these options and then run it as root and then type in password and then do commands that are there. You can see like I did. So let me just show you that part of it before I go to the workbench. Let's say I'm going to open up on my SQL command prompt here. So this command prompt, which I'm gonna just go to the directory where MySQL is, which is right there. And then from there, I'm gonna use the MySQL command with the default option of using this my.ini. And my.ini is the basically on Solaris or Unix machine. When you do this one, this would be equivalent to Linux machine is my.cnf. The path, wherever you installed it, that would be the path for that file. So inside there, on the my.ini is initialization parameters of your instance. So sometimes like on Oracle, you have Oracle initialization parameter file, how to start up there, and then you set up your Oracle's ID and the user interface. So in the MySQL instance, you have this my.ini for Windows for initialization. On Linux, this file would be my.cnf. So let me just go to C program files, So if I just do this, that's good enough for me to just escape. I could also do the backslash space and then files. I could do that, or I could put it within code. It would work the same way. Now I'm going to go to my SQL directory. And here, as you can see, that there's a number of other files, but the one that I'm looking for is MySQL Server 8.0. So I'm going to do MySQL backslash space server backslash space 8.0. Did not understood that one. So I'm going to put it within code. Does not understand. I'm gonna try this. I know it's server, and then doesn't matter here what it is. This one would work. So already changed to the directory that server, and then is going to. I think maybe let me just do the one thing here. This one, because I'm on Windows, maybe the backslash is forward slash. It doesn't make sense. No. So on MySQL, it has to be a backslash on the that as well, and but the syntax works no problem. So right here you could do go to the bin directory. Notice that I'm just right here on the 8.0, and then there's no MySQL here. So I have to do /bin/MySQL, but the MySQL server, there's a .ini file on the previous directory. So let me see the .ini file first. Directory MySQL.ini file. Directory store.my.ini/s. This will just find any file that are my ini file, and it is not finding anything with that name. Let's see if this instance has the MySQL server minus u. Okay, so at this time I'm gonna go to the bin directory like I did earlier, MySQL. Go to the bin directory, and then right here there's a MySQL.exec, which runs the MySQL client version of it. It connects it. There's a lot of other .exec file here under the bin, but like MySQL, for example, import and export, and other ones are there. But at this time, we're only like MySQL dump would be equivalent to export, and MySQL import is this still equivalent to import. Um, um, MySQL D is the daemon, that is a background daemon that actually connected is the server. MySQL by itself, .exec is the client. So in this case, we're going to connect to the client using MySQL itself. If I just type in like that, let's see if it understand. It prompt me for a username, password, or anything. So it says you are trying to connect through ODBC at localhost, but you did not provide any username, any password. So let me just say MySQL minus u for user, and then I'm saying root, and then minus p, prompt me for password. So I'm going to type in the password, and then I'm going to type in the password, and then I'm going to say it actually did connect me. So I did, all I needed is a username and a password. And in this instance right now, I'm connected through MySQL. So this is a developer version of command line interface for a client that it shows that I'm connected to a MySQL server. And then on the MySQL server that I'm connected on right now, I'm using the root as the user, and then the rest of the information. So at this time, if I just want to know about my server status, I could say status. And then it says MySQL version 8, Windows 64-bit is running. Let me make these other screen smaller. Actually, I make this one bigger. That's good enough. So you're not seeing extra information there. So at this time, if I just did that one, the status, it shows that I'm connected to an instance of MySQL. And then if I need further help, I could just say H. The \H. So \H is saying that give me help. So if I want to connect to a server, I could say connect and then the name of the server. And then get help, for example, is equivalent to the /h. Status was 1. For example, if I want to do S like this, it's the same thing as status. All right. So like, for example, T command, this is just to capture it into a file. A status, you already know that status to give you the status of its system. For example, if I want to do system and then directory, notice that every time that I type in system, I could do the command that I want to do. If it is a command that is Windows based, then it will work. So system directory star.py, I don't have any .py because I'm on that directory, but I could say c:/user/wahid/python/star.python, and then that would display the path to what I have. So in this case, if I just want to see, for example, look at one of them, let's say system notepad, I'm just showing you that while you're in MySQL, you could run something like that and see help, let's say, .py. And then you can see that it just opens that one and manipulates set. Let me see the notepad. So I need to do alternate tab to go to the last session that just opened. This one. I'm going to close it, and now my system has dropped back here. So I say status, I'm connecting to this instance. And then if I just say \question mark, it shows me all the information here, system, use. On Oracle SQL, also you have these option of show user, show status, show different version of it, right? Information. But status itself, it gave you enough information about saying current user is root at this local host, connected ID is 41, and then there's a port, obviously. What is the port here that I'm connected to? MySQL, right here. The TCP port, this is very important. By default, in this case, is transmission control protocol port is 3306. That instance is going to be running under port 3306. So if I'm just connecting to a different port and I cannot get connected, that's obviously a problem. In order for me to connect to this instance correctly from a remote site, I have to have the username, the host name, the port numbers, and then the local host, the host ID, the username, the password, and then the port number. Those 4 parameters or 5 parameters, you have to pass it on. So in this case, is different than SQL. Now, if I say show databases, remember we were looking at the actual command on on the SQLite. In this case, we're on a command line. So it's all based on the query that you're putting in and you're doing it. And then when we did describe, let's say table 1, it says that table 1 describe was unknown. But in this case, we're on the full-fledged of MySQL database. All of the commands that we want to run, it is going to work here. So let's say we're going to look at the MySQL database here. This is the data dictionary for the MySQL. The system tables or data dictionary table has information about how the users are defined, how the database is defined. All the data definition part of that one is written in the data dictionary, all system tables that are internally hosted there. So now I'm going to say use MySQL. In order to use that database, I just changed my database to say use database. Now if I say show tables, it's going to show all the tables are within this. If I say show databases, it's going to show all of them that are available, but currently I'm going to use the instance of that MySQL. So if I say show tables, notice that there's a lot of tables, 33 tables. One of them is, for example, DB table. The other one is user table, right? So if I just say describe user, this is the user table. Notice how many fields are in the user table. And the reason that are important of that one, because it's a full database. It is not just a small 3 lines without any primary key. It's not a flat file. It's not a SQLite file. It's a database file. SQLite could also be considered as a database file, but it's a lighter version. So in this case, the host information and user ID are defined as primary key. And then these ones could take accept null values, and then there are data types of characters, enumeration, and these are null values or there. Um, yes, no, and this is enumeration. They take a value of true and false. Yes, no, and this one is even the data type is JSON. This one is blob, and then this is character set text. So you can see timestamp. It supports a variety of other ones there. So if I say select a star from user, and notice that how many users are there, 6 rows, but I'm not interested on these other extra information there, but there might be a password there that's also there. Was there any field here on the database? This is username. Maybe there's a password field on the user that when we do alter in other ones, it actually modifies it in this one. Let's see. Yeah, there's password expired, password last change, password lifetime, account locked, and password reuse history, password required. So a lot of password related entries, but then the actual password file might be a primary key on another table. So describe DB. DB is the table that has also this user as primary key, and then DB is one field of it. So select privilege, insert privilege. These are the control grant data control language that you could say give select privilege, insert update, and all those options to a user, index privilege and triggers and so on. So show view, show this, drop, delete. Let me see, show tables. Um, okay, user, server. So server has it, password history is there, a function, password, column. So I could say create user one, identified by password 123. Just temporarily see if it allows me. User one identified by password line 3. So it did not allow me check the manual that correspond to this one. Create. So this one I have to use the word create user. Create user one identified by password is the right syntax. Let's see. Um, Identified by password. I'm gonna put that one within the code and right syntax. You have an error in SQL. Check the manual that correspond to create user. Identified might be typed in wrong. Identified. This is how you write identified. It's maybe I typed it too fast and I just did identify D. Okay, so now I typed it correctly. Create user one identified by password, and then password is password 123. So now I say at this time I say grant connect and then I could say grant all. Just let's say all to user one. Let's see what it says. Grant. Um, you have an error in SQL. Check. Grant connect to user one. Connect to user one. Okay, connect at local host. Okay, so unknown authorized ID, that makes sense. Let me just see by default if I exit out of this one and I just use password 123, can I just log in with that the user called user1, and the password is password 123. Yeah. So by default, the connect and other privilege are already granted to this user. But now this user has um, maybe limited resource. When I do a show database, this person cannot just create another instance of a database. So all of this, that information underscore schema as a database is there. The MySQL DB and other ones that were there with the root privilege, because root had a higher access, it's not available to this one. So if I just say create a database demo one, and then say that one, it just access denied because I'm not having that privilege. But if I say use information underscore schema, this is going to be okay. Show tables, this is okay because all the tables that are on the information schema, all the views and triggers, tables and everything is all available for me. So at this time, if I just say show the user tables, I could do that. So show select describe tables, and then you can see that when describe views, it is there. So select star from views, and then at this time that one doesn't have anything. How about the tables? Tables have records and other things. So you could do where clause and other stuff and so on. At this time, I'm gonna just exit out of this and then go back, log in as root, and then so at this time I say alter user user1 identified by new password, new pass 123, and then semicolon. Now I just modified their user there. If I want to grant a certain access, I could do it, but I just don't want to because I want to do the Python part of it. I'm going to drop this user, the drop user user1, and then that is already dropped. So next time I exit out here, this user1 comes in, try to log in, it's not gonna just be a proper user. User1, whether you type in new pass 123, is gonna say this user1 does not exist, or I could say password 1234. It is not gonna work because I dropped it. So that is good enough for this part. Let me start another workbench, MySQL. So when you install the MySQL client, at the same time, you can install the MySQL workbench. This is similar to your SQLite interface in a GUI. You don't have to do what I just showed you on the command line. Obviously, you could create tables the same way you did it here with those options, and you can come up and do it in here. So you can see this instance that I'm connecting at the same port is available for me. In this plus symbol, you can add more instance if you want to. So since this one I created at a time of installation, I'm going to log into that instance. So now I'm logged on to the MySQL workbench for that instance. And then this instance, based on the tables that I create, based on the objects that I create, based on any object, table, user, views, anything, I could manipulate data. And then the interface is that you have a database here that you could say connect to the database, and then you just say, yeah, this is my instance that we just looked at the control panel that is there. Its host name is localhost, port is this, user root, and then I just say, okay, go ahead, connect that one. At this time, I'm getting that connection, and then if I just say show databases, show databases, the same way that we did on the command line, you could run it here. And then this one just shows the database here. So if you say next line, say use MySQL command, and then run that, and then notice that it already changed it. So I'm gonna do say next line, say describe MySQL, actually DB file, DB table. So this one is gonna do that. Notice it ran those other commands as well as this last command. The last command is displayed. Similar to Panda on the Python and other ones. Your last SQLite, we also experiment that one today. And I was saying that maybe it doesn't show, yes, it does execute this statement, but it only shows the output of the last one. It does not show the output of the other one. But because this one is successful, I know without not using this one, I could not say describe DB. So if I just take this one out, let's see what happened. And I just say that, actually, I'm already connecting it to it. So let me just say, I'm gonna do this and then say run. And then I say use sys, and then show tables, and then run it. So that under the sys you have these tables. System tables, there might be a password database table also, because it has a user. I think the user itself, and right here, password history. There might be one field here long time ago. I remember I experimented and I found that actual under the function, you could just even pass on the connection to change it. Okay, so if I just say select the star from select a star from sys, no, from user. Sys is my table, and there you go. All the tables, DB user, localhost, and the rest of the parameters. But let's see if I just now when I say use DB, can I say select star from MySQL.db? So in this case, I'm specifying which database it should go and what tables it is going. And the other one, it was not. And now here you could do it. So if I just say here, use use sys, even though I'm here and the sys, and say and describe DB, this one will just give me the DB of the sys, but then I say semicolon, and then put semicolon, and then right here I say describe MySQL.db. So here I'm forcing myself to use the sys database. And then I say describe the table called DB inside the sys. But while I'm there, I also want to say, show me the database of MySQL.db. So the MySQL.db is a little bit different than this one. This one was showing show databases, use it there, describe DB. It did not list it. Let's see what it says here. Yeah. This one at MySQL DB is a lot different because I said, show me this one. If I change that one to by itself, which I did up there, or I say sys, now this time I run that sys.db and execute it, it's only that. So yes, you can go between different tables and while you're there, and that's what I wanted to show you. For example, you could say create table, um, create table my DB as, and then remember this syntax was not working on SQLite with the bracket. The right syntax is like this on MySQL. So create table my DB as select a star from what I'm picking up. I'm picking up create table my DB as a star from DB. So this one I want to just create it from MySQL.db. Okay, that one I will create. I'm gonna say my for MySQL and then sys for the other one. So let me create this one and say now that created, and then my DB. I'm gonna say this one sys from sys.db. Sys.db. So these two table, one of them is sysdb, the other is my.db. I'm going to create them, and then now I'm gonna do describe. I don't have to do show database. I could say describe and describe my and db. This is from the mysql.db file, and then you can see it is much larger with those definition. And if I say sysdb, this is 5 field or 6 field smaller. So sysdb, sysdb. This one did not create it maybe successfully. Create a table sysdb as select star from sys.db. I don't know if sys.db had the table there, but I will check if this one and doesn't fail. Doesn't create a table sys this. So table DB doesn't exist. That's why I could say user, and then sys user. So now I create this user. I know it says it had a user table, I believe. Let's see. Doesn't have it. Let me just see what is on the sys table that we can say. Use sys show tables. So by using sys, we know that you're using, so sys has these tables. Is there any user table? No. Version is there. MyDB. Oh, MyDB I created inside because I was using inside there. Okay, that makes sense. So I'm gonna say and sys drop a table MyDB and this one drop. Okay, sys user doesn't exist. Okay, that's fine because we deleted already the first time. So show tables and let's see if MyDB is there. Oh, this show tables, yeah. share tables, use sys. Use sys and draw table. There's this typing of draw that's not the right one. It still has the previous syntax. So show databases. I want to run this one first, and then I get that one. Now I say use sys, and then I'm running that, and then say show tables, and now I get the tables, and my DB should not be there anymore. It is there. So I'm gonna say drop my DB. I'm gonna say describe my DB. It is the same one as the other DB that were there, yes. So I'm gonna say drop table my DB, and then 0 row affected drop table my DB. Let's see if it describe. And sometimes if it is, yeah, it's gone. My DB doesn't exist. Okay. So if I say show tables, yeah, it's gone. So now I can do a commit and then make sure that changes are taking effect. Commit affected right there. So by automatic, if the commit is automated, then this one will show that it's already affected. So 0 record affected. If it is not automatic, then and then when you do the commit, it will just say how many commits were submitted. Okay, so we did the database. You could also go here and then create queries. You could run queries. You could, let's say, create new table. If you create new table, notice that this one is such a nice interface. While you're doing the query, it's also doing the commands here, the actual one. So if I just say create a table, a student, let's say a student, and then want to just say a column name is first here. So once you say student, I want to just say don't create a schema. At this time, I'm going to go out of this database. I'm going to create it on my own database, like new DB that we created. So before we create that table, we need to create a database. So we're going to go here on the database and then say new schema. We're going to say new DB. So this one is new DB1, similar to MySQL, but instead of that dot, and similar to SQLite, but instead of giving .SQLite, we just say new DB, and then the rest of them, the database files, control file, log files, you will see that they grow as we create them. So at this time, right now, in here, there's a directory called data files, right? So let me see where the data file is in here instance. Normally on the initialization file, my.ini file or my.cnf file, normally in that file, the data files and control files, log files, all of that one is there. So let's see outside here, .c++, MySQL, SQL Server, Workbench, directory, store.ini. Okay, nothing there. CNF conf sample MySQL router.conf file. No, directory star SQLnet. There's something called TNS name.ora file for Oracle. So similar to that one is something here on MySQL that could have the initialization files. But let's see if it finds it from the show instance that we did. So if I say cd2 start to my, can I say MySQL here? No. So MySQL server 8.0 router. I want a server direct cd2 start server 8.0 and then SQL bin MySQL MySQL minus u root minus p and then status. So MySQL client connection con is cp8 hexadecimal values. Okay. Let's see on the GUI interface, export data. Okay, so this is the, if I wanted to data export, data import, users, client, server status. I want to see that server status and they give you more details of the connection. This is program file, MySQL server, my.ini. And this file is actually not there. I didn't, oh, program data, that's where the data file is. So normally the Oracle database and MySQL database is getting mounted on a separate partition because you don't want your binaries to be the same location as the actual data file control files. So this my.ini, as you can see on the configuration files, it is in the program data directory. So in order for me to go there, let's say program data, this one is actually the entire thing for MySQL. And you can see that this is data file for MySQL or Oracle instances, MySQL server, and then my.ini. But inside there, then it tells me what I'm using for my database files and so on. So I'm going to go to SQL Server 8.0 and then more my.ini. This is the file that I was telling you about my.conf file on the other ones. So this is the initialization parameter for MySQL. In this case, it says that go ahead, use this initialization parameter. Wherever it's commented, you don't need to worry about it. But at the same time, if you just want to enable something, then you just have to uncomment it out those lines. So MySQL pipe, let me just go further. This is telling that use the MySQL command to start in on this port, and then socket is using a MySQL socket connection. Pipe is equal, and then connection MySQL. If you're connecting to a socket, right now we're not using socket, we're using port through TCP IP, and then the MySQL daemon is the binary port, no beep default, and MySQL D is the instance right here, the server, and server type is 3, and then the 3 is just setting a certain values for it based on the criteria, how much memory and how much SGA and other things that you want to define. So general purpose log SQL program data, MySQL server data. Right here is that data directory. So this is what I was looking for. The data directory, in this case MySQL, is when you install it by default, it installed it under C program data, MySQL server, and then data directory. And then inside here, when you create a database, it will just be all that information in there. So let me just, this is all done. Let me just show you inside here, there's a data directory right there. At this time, any DB files, anything, let's say if I do a more on this stop, this is auto.cnf, auto configuration files. The PEM files, the certificates, like if you're going through a secure port, transmission control protocol, as well as SSL, secure socket layer, TLS, transmission layer security. Those kind of things are all are built in within this to say that you're doing a transaction that is secure. And this is the MySQL directory demo1. So inside this one, we have a database called demo1. Let's see, cd to demo1, which I created earlier based on my things that we wanted to do. I created this employee. And then you see that this one is IBD. Maybe it stands for initial buffer data, whatever it is, IBD. I don't know the extension. Normally on Oracle is DB files, but this is all data files that are just built in for that instance there. So test table.dd manager. Each table has its own initialization, maybe block of data or something. But each table, employee record, these are the data files. If you're on Unix, if you type in a file followed by this, it will say these are data files. You cannot do a more or type it because you cannot see the content of it. It's gibberish. If I just say type something like this, it's not gonna just, it might just hang up my screen or something, or my session. You just don't want to do that one because these are type. There are tools that it reads it, and one of the tools is SQL. Workbench, MySQL Workbench. Another one is MySQL that you do on this case. So we found out the location of demo1 table, and then right here, if I just go to say open database that are already there. So let's say here, create a database, we create it and we say open, let's see which one is the open. Yeah, connect to the database here. And then here, we're connecting to localhost root default schema. Let's just say demo1. We connect to that one. Now we just connected to that one. I'm gonna run show tables. Right here, I say show tables. Sorry, show tables and run it. And then notice that exactly what I'm seeing here. This is nice thing. Employee, manager, and test table. It is, let me make this screen a little bit smaller. So I'm going to do a clear screen here and then do a dir, clear screen, do a dir. And notice that this inside this data file, demo1, I'm using the demo1 database on the workbench. Oh, shoot. This thing is taking a long time to just display it. I'm going to close this one and close this one. Okay, right here is demo1, and you can see that employee is one-to-one. Right here on this screen, I have employee table, and here I have employee manager and test table. So now if I just add another table here, from employee 1, if I just say create table employee 2 as and then say select a star from employee, then notice here I have these tables. Let me close this one and right here. Notice I have 3 tables here and I have 3 tables here. But if I do this statement, it's going to create a table called employee 2. Then I should have on this data demo1 database, I should have another database here. And later on, when I do a show tables, and instead of 3, it should show employee 2 as well, in addition to those 3. So let me just run this one. It just say that 3 return, create tables, 1 duplicate, 0 this. So it already successfully created. Now let's see if I do a show tables here. That table already existed, so they didn't do it again. Show tables. Now it's going to be 4 records with the new employee 2. And then here, even though it shows 3, I need to do another dir command to just see the change, because that was from previous one. Now I can see the next one, employee 2, is there. And then again here, whatever I type in here, say drop table employee 2, and then just run it. And then here, now the employee 2 is gone. Now it's 3 of them. And then here showed this. One thing I want to show you after this is to create a view, see if a view is inside a table or it creates a separate file here as well. So create, so show database, show tables, and then you can see that there's 3 now. I'm going to say create a view, my view as select. Actually, let's do a describe first. Describe employee. So I want to see what I can view from it. Let's say I want to do first name and then last name only. So I say create view, my view as, and then say select first name, comma, last name from employee. That would do that. So at this time I created that one, and now I say show database, show tables is gonna just show the tables, but nothing with the views, and then here and directory, and then nothing with the view here, but because the view is somehow in there, inside the table space, but not inside the table. It's not a table. So that's a different files. Show views. Show view. No, show views is not like a command, I think. Yeah. So I could say select a star from my view. I know that that view exists because I created it now. Let's see. Limit 0, limit 1, select a star from my view. Demo 1 doesn't exist. Did I name it differently? I wonder what I named it. Is there like an option here to see your history? I believe there is one. Show history maybe. Show history. Okay, so I have it already here. I can look up, see what I did on the drop table employee to drop create view my view. Um, unknown column. Okay, so it did not create the first name. I'm going to recreate that view. I did not create it. I should have looked at it on this syntax when I was doing it. So my view does not exist yet. Describe employee. I want to make sure that I understand what fields are there. Okay. Oh, first name, last name. That's obvious. I should have read it. I just read it from my student table on my mind. I didn't even look at it. So let me just do that one again. Sorry about that. So I say create view, create a view, my view as, and then select first name, first underscore name, comma, last underscore name from employee. That would do it. Semicolon. Yeah, it is zero row affected, so that is good. And now I'm going to say describe my view is based on those two fields. That's correct. Now select a star from my view, and all of this one is inside the table space, okay, which is good. So now I go say the first name is Wahid, last name is Lutfi. Now I'm gonna say show tables. And then view is also listed here. And then here, when I do that one, directory now view is also going to be listed here. Show tables, and then why is not view listed here? And when you do here, show tables or demo one, tables, my view. Let's see, I do a commit. This is the part that I was telling you that the view is inside one of those tables in the data files. So the actual table space has views, users, and tables. So the tables that you create is separate, even though here when you see it or the show, it's a little bit inconsistent if it shows here as a table when that is actually a view. It shows here my view is there, and then here it doesn't show, but because I say inside a schema, in this case my schema is called demo one, you contain table spaces. Inside table space you contain users, uh, the profile, as well as the table space for that user, and inside table space you have tables, indices, and views, and synonyms and other objects. So is there a command table show views? No. We already tested that one. I should have not tested, but last time the create view did not succeed. That's why I wanted to test it. Okay. So at this time, we know that we're working on the right database, show databases. It's basically all the databases that are available, including demo one. And we could say use demo one. Inside this schema, what I'm doing, demo one, I could say use MySQL. So it doesn't have to be inside there and use demo one, but you could do whatever you want. So show, describe, and describe views, my view. It should say two fields only. first name and last name, and then if we have the view, like I told you earlier, the view is basically a narrower view of the data that you want to access, or give certain users the read-only access to certain views, so they can just query the data and then manipulate the data based on their knowledge of what they need to do, how they should filter it out. So at this time, I think I showed enough on the MySQL Workbench. There's all other options, and these are ones when you create the tables like you did on MySQL from the command line. It's the same thing as the GUI, as well as doing the query like I was doing here. The GUI is much easier to do it because you just create it and then put the name of the fields here, and then whether they're primary key or foreign key or unique key, you put it, and then the syntax will show up. So if I just say create a new table, and then say primary key, and then I say column name, whatever name at this time it defines it, and I say that's fine. And then the default collection, that's fine. Then I say another column, add another column. Let's see, this one, I say apply. And then this is the syntax on the data definition language. So it says create table demo one dot new table. Inside this schema demo one, it will create the table one, and then ID new one not null, and then it's also primary key. Already did this one. But if you want to add on more to it, you could just say, go ahead, add on to it. And if you say I'm done with it, this is just one row, it will just fetch the record, execute it, finish it. Now it just created another table. And the syntax were there are the things you could just cut and paste it and put it in your Python script. You could do that one similar to the way we did it earlier. So this is a very nice tool. It gives you all these options. You could go further that one, or you could just say back to the query statement here, say show tables. Now you will see another table that was added there called new table. And if you describe that one, describe new table, that one is basically having one field only, and then now there's no data yet inserted. So let's start from new table, nothing there yet, but we could insert, or we could do whatever we do. I just need to do it in here. So no records there, no, there. So let me go to MySQL. I'm in Python, and then this time I'm not using the command line as much. I'm going to use a PyCharm. PyCharm, so you could be exposed to many different tools and better learning. You already learned the command lines, you could do the same thing there. And then again, on the command line, I said I will not use anything, but when you do Python from the command line, it just opens interactively here, right? So let's say inside this one, if I just was using MySQLite, I could just say import MySQLite 3, not MySQLite, SQLite 3. I'm sorry, import SQLite 3, and right away that is imported. When I was doing the dir of SQLite 3, you can see that this one is having all these open. One of them, the one that we were using connection to connect to it. So this was the method connect, and then the instance. So if I just say import SQLite 3 as, and then say S, and then, sorry, import SQLite 3 as S, and then say s.connect, and then use the memory-based memory, and then this. Now, that syntax may be an invalid connection, but let's see, we say con is equal. So I did not understand, as though that one, I'll look into that one to see what is there. Oh, let me put this within code. Memory. Unable to open database file. So it is just that syntax. Con is based on memory. Now everything that I do is at that session, it is open for me to do certain things with it. So I could just say C is equal con.cursor, and then manipulate and everything, right? So all I wanted to do is later on I'll show you the rest of the things, because now I have to create a table, create a database, and this and that, insert record, which we already have the record, we already played with it enough. I want to dedicate this time, what is left is for MySQL, so we can do at least one example of Python. Here, this is going to be the same. If I do here, I say import MySQL.connector. Okay, this one is also available. So now I say dir of MySQL.connector. That module, you can see all these ones. This one also has the connected string, the cursor, and everything, but this is based on MySQL. And there's other Python MySQL databases that you have to do to install it and get it working. So at this time, I'm going to open one of them, because I already passed time that I could do at least one demo. So let's see, C colon user Wahid. I'm going to go there and this one, CIS 12, MySQL, and then inside here, let's call it create employees.demo. And as you can see, this one I already played around with creating it under the demo one, so that create employee already existed there. But let's see if we could just do a little bit modification and then create another table there, employee two, and then insert records and fetch it there. Excuse me. 1 second. Okay, so I close this one. Close it. System is getting slow. I'm gonna close some of these things that I don't need anymore. Okay, so even this, I don't need it right now. So at this time, let's say I have this MySQL, import MySQL.connector. I connect, as you can see it, I'm passing on the username, password. Don't worry about the password being there, but because I'm going to just get rid of it and change it and so on. This information is there. It goes to this employee table and then all that record. So let me just run it, see if it says with this information that we did. All other information are the same, like we did on the command line, except within Python, you open the connection, you connect to it, like that on the syntax. Once you connect it, you open the cursor, you create the table or drop the table if it exists. Since the employee table exists, I'm dropping them. Since the manager already exists, I drop them. So the program should work because it is going to drop them. Then it creates it. So this one is successful. And then I executed it, commits it, and then insert one record, then insert create table manager as a result after the fact that the employee already exists. So this one, select first name, last name, manager from employee, and then describe those ones. So this one should work. And then show database and everything else. So let's see, we run it. If it doesn't work, then that means that I have to do a pip install some modules for this one within the virtual environment of this instance. So let's see. Because I did it last time, it should still have the same environment already exported, which is there. So as you can see, it did all the work there. It did that select statement after the inserting it. So at this time, it created the table successfully, and then it ran the SQL statement, it inserted the record, and then create the table, and then did the select statement here. The select statement, it just fetched one record here, and that was this, and then describe employee. This command is going to print this first name, last name, the how the data definition of the employee table is, and after that it just run the describe employee table, and then show database. It shows all the databases, and then show database. It was used on the output where it says show database first, right here, and then this is actual the database instance that are there. Notice that these data that are coming as tuples. Tuples or tuples is the output of these query, whether you're doing this, if you want to insert it into a list and manipulate them or something, or you just want to print them. As you can see, when I printed this row for the select statement right here, I printed them as a tuple. But then if I want to do row sub 0, and this one, this would just give me Wahid only if I run it again. This one will run on only Wahid there, say run. And instead of Wahid, Lutfi, and all other ones, I could just say, show me only the first row and the first field in this case. So let me run it again. Run this. And notice everything else is the same except the field number 1. In this case, I printed that one. Obviously, if I want to do more than that, I could just say, for example, right here, say for a row and cursor and then sub. And this one, I could just say what I want to pick up from cursor 0 through end of it, right? And then I say 1, 2, 3, 4. Then I say print row. That this one will just say already that I want to do this. And then right here, I could just print it one time like that, and then the other time a separate. And just because these ones are giving me more output, I could just comment them out, or just don't comment it out and just say run and execute them. Let's look at the output afterward with up arrow. And this thing in Python is neat. So somewhere it failed. My cursor, my SQL cursor. Let's see. For row and row and MySQL cursor line 35. So 35 is this line. It did not understood cursor colon sub zero. It yeah, I could say length of this one, length of the cursor. Um, length of cursor, and let's say for row and cursor, and then length of cursor, I could say let's say a row. A row is the number I want to print. Let's say I want to say dot okay, I'm going to say row, and then comma, dot, comma, and then row, sub, row. Let's try that. Because this one will give you the index if it does, and the other one should give you the code. Okay, line 34 for row and length of cursor has no length. Oh, so since this one is not uh, um, cursor is not like a string that you could say length of it. Cursor is different spatial uh, way of connecting to a buffer. So let me, it's a pointer. It's not a string, so there's no length for it. But let's try this, row of sub zero. I believe I could do something like that. Cursor sub zero, row sub zero. Let's print it. I could get an enumerated type if I do using enumeration. Maybe it would be better for this. Yeah. So in this case, it did work, but it printed out this information, and then after that one, it did not do anything here. It did not understood that syntax there. Row sub zero. If I want to just print out row sub zero so many times, let's say I is equal 0. You could use enumeration to just do this, but I'm just going to try this one first, and then I. So this one is a print row of cursor. Everything else is the same. That one, run it. So it did work, and the printing is not done. Why is the printing is not done? 0 sub I, y heat for I, describe row. maybe the cursor is not having any record anymore. Let's see this one. When you fetch it, it is already, the cursor is already read to maximum, I believe. And then the next time you do another one, no, it is execute cursor sub I. So it prints only the first one for row and cursor. And if I print this one to 1, it's gonna print the look fee, but it did not increment this. Yeah, that one is, yeah, look fee. So why is it not going through the second and the loop? For row and cursor, do and this, and then increment. Maybe they put an extra space here, that's why. Yeah, I'll just have to look at that one afterward to see what's going on. But for now, I'm gonna print out the row, and right here, I'm gonna do the same thing. So that will print the entire tuple, and then maybe I could assign it the tuple to something else, and then do that one. Maybe I could do this. Let's see. T is equal row. Um, Control X, and then put this one to the tuple to let's try one more thing before I quit on this. T is equal row. Row is there. Now I save for my T, for T tuple and my T print T, print T, the tuple, each one of them. So for row and cursor, assign the rows into my T and then print it. This might print duplicate, but it might print exactly what I'm looking for. Run. Yeah, this is exactly what I was looking for. So I wanted to print the Wahid Lutfi, the rest of the information in one row. So I assigned the row as tuple to a tuple. Now I'm putting the content of tuple to print it. This is how you do that one, to just access individual fields within a tuple. So now you got that one as well. Okay, let me uh, check and wrap it out here. In this case, I want to show you something that whenever you use PyCharm, if you set up your development environment, like in this case I did, you see this tab here? This is the database tab. So inside here, I could configure PyCharm to work with Oracle instance, with MySQL instance, with Postgres, with SQLite, and other ones. As you configure it for each one of them, inside there, you create this schema, and then inside here, you could just have the connection. You could test that the connection, for example, if the connection is within that environment, within the password that you do, it's successful, then you can go and then, sorry, root and then password is. So if this successful, then that means your connection inside the database is also going to be successful. Because when you do import MySQL, this has to pass, this test has to pass. So if this test does not pass, what you want to do is go back here. So let's say this test failed, you want to go under File, under Edit Setting, under Settings. You go under Setting, and then this interface comes up, and then you see the project interpreter. In this case, under my project interpreter, I have already installed the required Python with encryption, Python MySQL client, MySQL connectors, and all that other things that are there. If none of them are there available, you could click on this plus symbol here and then search for it. Let's say MySQL, and then you look at the client. I already have installed it. The ones that are installed on your system or color coded with blue, so it is nice and knowing that this is there. For example, if I don't have the MySQL connector Python DD data dump or something, then obviously I have to do data definition or data dump. Then you have to do that there. If you have not done the RF, that one, you just have to click on it and then say install package. Then that package will be available. So if I just say try install package RF, it says installing, and if it's successful, it will tell you. If it's failing, then whatever modules that are dependents, sometimes they have recursive dependencies after dependencies, you have to meet them in order to meet that requirement. So it says installing, and it's going to go through the installation of that. And if I don't need it, I don't have to install that package. There's based on what is failing for you. So for example, if the connection, the login password comes out with some SHA that does not pass, like this one, look, it failed, and then it tells you the detail what it is missing. So in this case, it's the MySQL connector RF. It requires all these other things that I need to do, and I don't need it at this time, so I don't need to do the extra work for it. But MySQL connector, the one that I'm using, MySQL connector, is right here. It's already installed on my system. So if I just do that one, and that package is already there, I could just say install. It will do the same thing as if I'm just going in the console. In the console also, like right now, it's doing the successfully installed, because that was working. I was able to connect. And then in addition, you have the PyCharm terminal. In the PyCharm terminal, you can type in commands that you could get from the operating system. Like here, you could see, for example, if I do a dir, I'm inside the operating system of that directory, create employee.py. This is a virtual environment. If you could see this, VNV, that's inside my Python environment that I have already integrated the development virtual environment, that every time I work on it, this is my environment, my profile, my virtual environment. So that is already programmed to work with MySQL connector. If later on I'm going to somebody else's session and then go to say Python is not there, then all I could do is look for Python pip and search MySQL.connector and so on, and pip install, pip something, pip install, pip update, pip search. So if that wrapper is already there, you can see lightweight wrapper for MySQL, it is there. If I just say pip just by itself MySQL, there's more than just one connector modules. MySQL, the big, and then you can see the whole thing. And if I just go to this interface so you can see more data, you can see that this is growing. Imagine how big it is for you to do whatever you do on this. So on this case, if I say pip search SQLite 3, this one was the one that we work on, the other one. So if I open any of my pip uh, Python scripts inside the PyCharm, and if it doesn't work, I know what modules to enable. But if I just say import SQLite 3 and then I make connection and I can see that the database instance get created, then I'm good done. I don't need to do further. Okay, that wraps up for this session. I am already passing behind the scheduled time, but I wanted to finish everything with MySQL, and then since not that many people were logged on, so I could just continue on, and hopefully you will have enough information at the end of this week submitted on the class Canvas. I'll post it there so you will have everything. Okay. I hope everybody has a great weekend and then enjoy the rest of the weekend. And I hope you all are in safe place and practicing the social distancing. That would be great. Thank you all. Thank you, Kyle.
Thank you, Professor Wahid.
Thank you, Rosalanda.
Bye bye.
Bye bye. You guys have a great one.
Keep safe.
Thank you, you too. Bye.
Bye.